now. My name is José Machado. I'm from University of Minho in Portugal, from the domain of mechanical engineering, mechatronics engineering. And I would like, before starting the video presentations, I would like to present or to mention about the works and the authors that will present it. So we will have 7 papers in this session. The first one, the title is The Behavior of a Rod Beam Under the Influence of an External Power Load. The presenter will be Konstantin Svirzewski. I'm sorry for my accent, but he is from Lutsk National Technical University in Ukraine. So it will be the first presentation. The second one, it will be, so I have been informed that it will not be presented. It's paper 4.2 in the program. The second paper being presented, the title is Rotor Dynamics and Stability of the Centrifugal Pump CPN 635 for nuclear power plants. The presenter will be Anton Verbovsky from Sumy State University in Ukraine. Third paper will be, the title is Organization of the Transportation of a Particle by an Inclined Cylinder Rotating Around the Axis. The presenter is Tatiana Volina from National University of Life and Environment Sciences of Ukraine. Fourth paper, the title is Vibration Reliability of the Turbine Units Housing Considering Random Imperfections. So the presenter will be Sergei Krashinov from Kharkiv National Automobile and Highway University in Ukraine. Fifth paper, title is Influence of Horizontal Inertial Loads of the Operation of Overhead Crane Girders. So the presenter will be Alexander Fomin from Odessa Polytechnical National University in Ukraine. Sixth paper, supersonic flow in the blade channel of the nozzle with a rotary diaphragm of small degrees of opening, presented by Olena Audievia from National Technical University, Kharkiv Polytechnic Institute in Ukraine. And finally, the last but not least, mathematical model of lifting particles of technological materials by vertical auger. So the presenter will be, again, Tatiana Volina from National University of Life and Environment Sciences of Ukraine. So I would like to thank all the listeners and the presenters in this session for the good works that I have seen. So I was reading some papers and I think there are some good works, and you will see the presentations. And I would like to ask for the technical team starting the video presentations. Thank you very much.
Good morning. A report on the topic is presented to your attention. The behavior of a rod beam under the influence of an external power load. Introduction and major challenges. The study of wheel bodies is currently under science and behavior of parts and then model can deform. Strain is the physical quantity the result of the forming load that in change the position and dimension. It is important to take into account the definition of all possible size of elements of any structure in which the size of the part and sign shape will not access specify values which are mainly determined by the operative condition. It is also important to remember the stability of the structure itself, the ability to imitate the shape of the balancer and size. It should be noted that the formation of bodies is a process caused due to application of external force loads to them. When the body is critical, dangerous points lies across section of the part deformed the move to another plane opposite relative to the original initial position. Thus, one of the most important texts of applied mechanics is to assess the strength and rigidity of any structure to ensure reliable and true dimension on the cross section, the part, as well as the study and research of the basic principles of operation of mechanics on the device under arbitrary loads. I'm a research task. The research aim is to relieve the dimension of the cross section of a part rod using SolidWorks software products which is affected by external power loads. Research text. Research maximum value of the stretch which occurs at center point in the cross section and which acts on the part and which is distributed evenly. The rest of three main strength condition will vary within acceptable standards will allow us to assert the ability of the calculation results. The research load and voltage distribution occurrence of deformation in the part structure. Part stability margin coefficient, natural frequency, fluctuation in the shape parameter, temperature distribution in the part structure beam rod. The mass and moment of inertia of this model reality to the x, y, and z coordinate system. Research methodology. 3.1 This slide is presented basic coordination for the strength, rigidity, and stability of the part. The following main elements of the study should be taken into account when calculation strength. 1. Design calculation. 2. Verification calculation. 3. Correlation of the distance and tested calculation. 3.2 This slide is presented the theoretical part of checking the strength of a beam rod. In the to implement and test the strength of a beam part, three main strength conditions must be met, which are presented on this slide. Figure 1 shows plots of external trash and which are affected by and values of stresses at the dangerous point end of the section. From the figure 1 it can be seen that normal forces that occurs in cross section is determined by the cross section method. In the case each section divides the beam rod into two parts. In the case the actual direction of the normal force implied in relation to the cross section in establishing when considering the equilibrium of one part of the path to another. Results 4.1 Model of behavior on the rod beam in the calculation of technique compression. It should be noted that eine tensile compression calculation on the basic strength must comply with state mathematic norms. Figure 1 shows the cross-sectional real individual prices where an external power load applied. Point 2. Ensuring being strength based on static equations in figure 3, the load diagram and force plots as presented as well as the bending moment of the beam in recorded. The main parameters and limit so permissible norm of reference reaction which were obtained based on the study. Figure 3 is presented in table 1. 4.3 behavior of a part beam units computer model is this slide figure 4 is presented part model unit the SolidWorks software system where a part model beam rod B generation of a finite element grind of the part beam rod. Calculation. It was found that the maximum value of the stress range from 70 megapascal to 170 megapascal, which occurs at 13 points in the cross section and which acts on the part and which distributed evenly, and the same time all three main strength conditions are met. Which line within acceptable standards which allow us to assert the reliability of the calculation results. Based on the calculation made, the following main factors were predicted. 1. Low and voltage distribution. 2. Occurrence of deformation in the part structure. 3. Part stability margin coefficient, natural frequency fluctuation, and then shape. For preliminary temperature distribution in the part structure beam rod. 5. The moment of inertia of this model reality the X, Y, and the coordinate system. Thank you very much for your attention.
Dear colleagues, my name is Anton Verbovoy. I am PhD student of Sumy State University. I would like to present the main results of the research work, rotor dynamics and stability of the centrifugal pump CPN 600/35 for nuclear power plants. All the authors present Sumy State University, particularly professors Ivan Pavlenko and Vitaly Simonovsky. There are doctors of science and professors of the Department of Computational Mechanics named after Volodymyr Marcinkovsky. Associate Professor Alexander Ivchenko, PhD and Associate Professor of the Department of Manufacturing Engineering, Machines and Tools. And Professor Vitaly Ivanov, Doctor of Science and Head of the Department of Manufacturing Engineering, Machines and Tools. Ensuring energy efficiency and vibration-resistant reliability of centrifugal machines is one of the priority tasks in their design and operation. The solution to this problem is to ensure the stability of rotation and low vibration level. This is aggravated by the presence of power machines, not only centrifugal forces caused by imbalances with frequency equal to the frequency of rotation, but also high frequency forces with frequencies many times higher than the rotor rotation frequency. In case of loss of stability, there are unacceptable auto-oscillations, characteristics of nonlinear dynamic systems. Their presence can be determined based on spectral analysis. In this case, the non-conforming state of the rotor dynamics can be detected by special equipment, which is not always provided with operating power machines. According to above-mentioned, dynamics and stability of the rotor of centrifugal pumps for nuclear power plants is a pressing problem, especially in the light of internal friction. Its solution is supplemented by modern computing means in their complex combination with analytical methods. Therefore, the main goal is to develop a common approach to ensuring vibration reliability of centrifugal pumps for nuclear power plants. The multi-stage centrifugal pump CPN 600/35 ensures the water supply for an industrial circuit at nuclear power plants. Its nominal parameters are feed 600 cubic meters per hour, head 35 meters, and operation frequency 1500 rotations per minute. Within the research project, fulfillment of tasks of the perspective plan of development of a scientific direction, technical sciences, ordered by the Ministry of Education and Science of Ukraine, has been developed the design of the centrifugal pump CPN 600/35 for nuclear power plants of Ukraine. Here are presented design and the calculation schemes of the pump's rotor. And here are presented characteristics of its bearings. The procedure of parameter identification of a single mass mathematical model of rotor dynamics is based on the hypothesis that the compliance of the rotor and its first eigenfrequency can be the same as for the finite element model. In this regard, the following equation should be satisfied. The model of rotor dynamics in a complex form is next. This model also includes the hydrodynamic forces, particularly damping force proportional to the velocity, and circulation force. The hydrodynamic coefficients are determined by the following dependencies. Additionally, the internal viscous friction force proportional to the relative viscosity is considered. Its value in the moving and fixed coordinate systems are follows. Overall, the initial differential equation of rotor dynamics takes this form. Or in projections on the coordinates x and y, considering this form. The dynamic stability of the rotor's motion can be studied according to the Rose-Hurwitz criterion. So the system of linear algebraic equations can be obtained this way. And the corresponding characteristic equation is next, where following coefficients have been introduced. The negative parts of solution determine the stability region of rotor movement. According to the Rose-Gurwitz criterion, this requirement is completely satisfied for the following inequalities. The first two of these inequalities are automatically satisfied. However, the last one leads to the following stability condition. So, in this slide, diagram of stability is presented. Using software critical frequencies of the rotor and ANSYS mechanical, first three eigenfrequencies and eigenshapes were obtained. In this slide, you can see mode shapes obtained using the program critical frequencies of the rotor. And here are same shapes obtained using the ANSYS software with values of eigenfrequencies. The table of results comparison for calculation using software ANSYS and critical is presented. The relative error for evaluating the first eigenfrequency does not exceed 2.2%. Therefore, the author's methodology realized within the operation file critical is reliable for the designed centrifugal pump CPN 600 by 35. The first three resulting mode shapes of free oscillations are presented at the slide. The comparison of the results obtained using the MATCAD and ANSYS software is also presented in the table. Thus, in this study, the centrifugal pump CPN 600 by 35 for the water supply of industrial circuit at nuclear power plants has been modernized. This design corresponds to national standards concerning rules and regulations in the nuclear power industry according to Energoatom requirements. For ensuring vibration reliability of the designed pump, the parameter identification approach has been applied jointly with the finite element analysis and analytical modeling. As a result, the equivalent mass and stiffness of the rotor system have been evaluated. The mathematical model of rotor dynamics has been developed considering inertia, stiffness, damping, circulation, and the friction forces. Based on the Rose-Gurwitz criterion, the dynamic stability of the rotor movement has been assessed in terms of operation frequency and friction coefficient, and the corresponding stability region has been built. Remarkably, all the scientific results were obtained within the research and development project fulfillment of tasks of the perspective plan of development of a scientific direction technical sciences ordered by the Ministry of Education and Science of Ukraine under the specific supervision of Professor Ivan Pavlenko. The authors appreciate the International Association for Technological Development and Innovations for the support while conducting this research. So, thank you very much for attention. That's all.
Good day, dear participants of the conference. My name is Tatiana. I would like to present you the results of our research on the theme, the organization of transportation of a particle by an inclined cylinder rotating around its axis. It's a well-known fact that cylindrical surfaces are an integral part of agricultural machinery. In hosting and transport machines, such surfaces are casing inside which the active working body rotates. An inclined cylinder that rotates around its axis is used in drum grain dryers and cylindrical separators. Improving the device design needs the patterns of movement of a material particle on the surface. So, finding these patterns was the aim of our research. The particle is at point A on the lower generatrix. Let us rotate the cylinder around the axis with a constant angular velocity. During time t, it rotates and its lower generatrix moves to point C. The particle also moves, but does not reach point C because it slides on it. Suppose it has reached point B, which corresponds to the angle of sliding alpha. Since the axis of rotation is horizontal, the trajectory is the arc. Firstly, let us consider the movement of a particle on the surface of a horizontal cylinder. The particle is initially located on the lower generatrix, and the angular sliding velocity is absent. The graphs of changes of the kinematic characteristics of the movement of the particle during 3 seconds period and different angular velocities are presented at the top of the slide. The horizontal part of the graph indicates that at this time there is no sliding. The particle sticks and rotates with the cylinder. The graphs of the change of the difference of angles at the bottom of this slide show the amplitude of oscillations. It increases as the angular velocity of the rotation increases. With increasing the angular velocity of rotation more than 10 seconds to the minus first power, the particle practically sticks and rotates with it. If at the initial moment the particle has an angular sliding velocity, then the further movement of the particle will differ from the considered cases. The character of the oscillations will be changed. Their amplitude decreases. Researchers have shown that the angular velocity does not affect the amplitude of oscillations. But let's apply the second initial condition. At the initial moment, the particle is not located at the lower point of the cylinder, but slightly higher in the direction of its rotation, namely minus 15 degrees. The amplitude of oscillations has decreased, and it's obvious that in both cases oscillations occur relative to the midpoint. It's approximately 17 degrees. If the initial condition is minus 17 degrees, the amplitude of oscillations practically disappears and the particle remains stationary. Mathematical calculations proved that if the particle hits the cylinder with a relative angular velocity, which is equal to the angular velocity of rotation and is opposite to the direction of its rotation, it continues to move with this velocity without oscillations. The kinematic characteristics of the particle movement inside the inclined cylinder significantly depend on two parameters, the angle of inclination of the cylinder and the angular velocity of its rotation. Figure shows the absolute trajectories of the particle for a cylinder which is inclined by an angle which is less than the angle of friction. Here you can see the graphs of the velocity change in the direction of the OX axis. In the case which is shown on the left, the angle of inclination is less than the friction angle, and in the case which is shown on the right, it's greater. It can be concluded that the movement of the particle is stabilized, its velocity in the actual direction is close to a constant value and the trajectory to a straight line. Such stabilization is possible up to a certain value of the angular velocity of rotation. With further increasing of the angular velocity, the particle sticks and rotates together with the cylinder. At low angular velocities of rotation, velocity stabilization is possible only for the angles of inclination of the cylinder which are less than the angle of friction. The graph on the right of the particle sliding velocity in the axial direction at an angle which is greater than the friction angle shows that the sliding velocity increases linearly. Here you can see graphs of changes of the sliding angle and the distance of the particle movement in the axial direction at the angle velocity of rotation 20 seconds to the minus first power. It shows that the sticking of the particle occurs when reaching the appropriate angular velocity at any angle of its inclination. So, it can be concluded that when a particle hits the inner surface of a horizontal cylinder, it begins to oscillate in the cross-sectional plane of the cylinder with a certain amplitude in the angular dimension. The value of the amplitude depends on the incidence point of the particle, the coefficient of friction, and the initial absolute velocity. Under appropriate initial conditions, which can be determined analytically, the particle in absolute movement can be stationary, being at a point on the cylinder at a certain distance from the lower point in the angular dimension, in the direction of the rotation. When the cylinder is inclined to the horizon, the particle begins to move in the axial direction while the amplitude of oscillation decreases. The angle of inclination of the cylinder is important. At an angle which is less than the angle of friction, there is a stabilization of movement. Oscillations stop and the particle moves straightforwardly in the axial direction with a constant velocity. At an angle which is greater or equal to the angle of friction, the stabilization of movement does not occur. The particle moves accelerated in the axial direction. The value of the angular velocity of rotation has great importance. When a certain value is reached, the particle practically sticks regardless of the angle of the cylinder. Thank you very much for your attention. Good day, dear participants of the conference. My name is Tatiana. I would like to present you the results of our research on the theme, the organization of transportation of a particle by an inclined cylinder rotating around its axis. It's a well-known fact that cylindrical surfaces are an integral part of agricultural machinery. In hoisting and transport machines, such surfaces are casing inside which the active working body rotates. An inclined cylinder that rotates around its axis is used in drum grain dryers and cylindrical separators. Improving the device design needs the patterns of movement of a material particle on the surface. So, finding these patterns was the aim of our research. The particle is at point A on the lower generatrix. Let us rotate the cylinder around the axis with a constant angular velocity. During time t, it rotates and its lower generatrix moves to point C. The particle also moves, but does not reach point C because it slides on it. Suppose it has reached point B, which corresponds to the angle of sliding alpha. Since the axis of rotation is horizontal, the trajectory is the arc. Firstly, let us consider the movement of a particle on the surface of a horizontal cylinder. The particle is initially located on the lower generatrix, and the angular sliding velocity is absent. The graphs of changes of the kinematic characteristics of the movement of the particle during 3 seconds period and different angular velocities are presented at the top of the slide. The horizontal part of the graph indicates that at this time there is no sliding. The particle sticks and rotates with the cylinder. The graphs of the change of the difference of angles at the bottom of this slide show the amplitude of oscillations. It increases as the angular velocity of the rotation increases. With increasing the angular velocity of rotation more than 10 seconds to the minus first power, the particle practically sticks and rotates with it. If at the initial moment the particle has an angular sliding velocity, then the further movement of the particle will differ from the considered cases. The character of the oscillations will be changed. Their amplitude decreases. Researchers have shown that the angular velocity does not affect the amplitude of oscillations. But let's apply the second initial condition. At the initial moment, the particle is not located at the lower point of the cylinder, but slightly higher in the direction of its rotation, namely minus 15 degrees. The amplitude of oscillations has decreased, and it's obvious that in both cases oscillations occur relative to the midpoint. It's approximately 17 degrees. If the initial condition is minus 17 degrees, the amplitude of oscillations practically disappears and the particle remains stationary. Mathematical calculations have proved that if the particle hits the cylinder with a relative angular velocity, which is equal to the angular velocity of rotation and is opposite to the direction of its rotation, it continues to move with this velocity without oscillations. The kinematic characteristics of the particle movement inside the inclined cylinder significantly depend on two parameters: the angle of inclination of the cylinder and the angular velocity of its rotation. Figure shows the absolute trajectories of the particle for a cylinder which is inclined by an angle which is less than the angle of friction. Here you can see the graphs of the velocity change in the direction of the OX axis. In the case which is shown on the left, the angle of inclination is less than the friction angle, and in the case which is shown on the right, it's greater. It can be concluded that the movement of the particle is stabilized, its velocity in the actual direction is close to a constant value and the trajectory to a straight line. Such stabilization is possible up to a certain value of the angular velocity of rotation. With further increasing of the angular velocity, the particle sticks and rotates together with the cylinder. At low angular velocities of rotation, velocity stabilization is possible only for the angles of inclination of the cylinder which are less than the angle of friction. The graph on the right of the particle sliding velocity in the actual direction at an angle which is greater than the friction angle shows that the sliding velocity increases linearly. Here you can see graphs of changes of the sliding angle and the distance of the particle movement in the actual direction at the angle velocity of rotation 20 seconds to the minus first power. It shows that the sticking of the particle occurs when reaching the appropriate angular velocity at any angle of its inclination. So, it can be concluded that when a particle hits the inner surface of a horizontal cylinder, it begins to oscillate in the cross-sectional plane of the cylinder with a certain amplitude in the angular dimension. The value of the amplitude depends on the incidence point of the particle, the coefficient of friction, and the initial absolute velocity. Under appropriate initial conditions, which can be determined analytically, the particle in absolute movement can be stationary, being at a point on the cylinder at a certain distance from the lower point in the angular dimension, in the direction of the rotation. When the cylinder is inclined to the horizon, the particle begins to move in the actual direction while the amplitude of oscillation decreases. The angle of inclination of the cylinder is important. at an angle which is less than the angle of friction, there is a stabilization of movement. Oscillations stop and the particle moves straightforwardly in the axial direction with a constant velocity. At an angle which is greater or equal to the angle of friction, the stabilization of movement does not occur. The particle moves accelerated in the axial direction. The value of the angular velocity of rotation has great importance. When a certain value is reached, the particle practically sticks, regardless of the angle of the cylinder. Thank you very much for your attention.
Brushing reliability analysis of the housing of the turbine unit considering random operation on the basis of the simplified model. HAKI-VKN. The induction changes. The EV power unit of the power plant is a complex system of the turbine unit and the generator connected by a common rotor and foundation. Typically, a single steam turbine system includes high and medium pressure cylinders, several low pressure cylinders, and the generator and the generator side. The most reliable are the outriggers of the low pressure rotor bearing structure made in one piece with low pressure harness with the rest of the foundation through the plate balcony. The result of the few tests was also the following model of the turbine unit. Low pressure, which is a complex system of shells, plates, and rods. Foundation, the forms of the system and plates and rods. Other equipment is modeled in the form of concentrated masses. Aim and research tasks. We will use the solution to the reliability problem according to the following method: creation of the mathematical model, construction of the geometric and computational models, conducting a series of cohesion of natural factors and forms of the system, verification of the obtained intermediate results, reliability, obtaining the reliability characteristic, analysis of the obtained results. For mathematical modeling, we will use functional approach of the theory of oscillation, reliability, and finite element method. Research methodology. Mathematical model for the analysis of the natural fractions is on the image. Mathematical model for the analysis of natural fractions and forms. The same mathematical model for reliability analysis. When solving the reliability problem, it is assumed that the rigidity of the body support on the foundation side the random variable whose probability density obeys the normal law with no parameters is average number value is variance. The maximum limit value C corresponds to a rigid surface. Since the stiffness parameter of the system under study at random natural fraction spectrum will be also be random. It is assumed that the small neighborhood of the natural values of the natural fractions as a function of sinuses can be approximated the Taylor series presents only linear terms. In this case, the relationships between omega and C will be linear and the probability density of the natural fractions will obey the normal law with mathematical expectations and variance. We recorded the equations 2 are determined from the relations for equations 3. The derivative is determined using finite difference equations. Central difference will be used in this paper. The vibration reliability of the system when considering files that occur that a resonant fraction in the operation range can be estimated by Fourier probability, which represents the probability of the natural fraction in the set operation formula 4. Numerical simulation. Based on the drama of real stem tumor, the basis of the geometric model was created. Since the use of finite method, the computational system was created. In the figure shows the symmetrical pattern of the low part of steam turbine housing for 1, 2, and 3 streams. The computational model has more than 3,000 finite elements, 3,000 nodes, and 19,000 degrees of freedom. The reliability of the frequency analysis results is based on comparison with another model which has 24,000 degrees of freedom. The average rate in the values of natural range is 6%. Results. Numerical operation with neutral phrases and forms of iterations are performed when varying the value of the stiffness of the foundation range fixing is known for experimental data that the stiffness of foundation individual elements can be very significant. Based on this, a fairly wide range is chosen to vary foundations. The calculations are shown in the table. Analysis of oscillation forms shows that the frequency beyond the local they forms are determined by the oscillation of interstructural elements, the housing walls, white walls. These frequencies can be cause of failure when changing the stiffness characteristic of foundation. They therefore can be excluded from the spectrum variability analysis. Analysis of the oscillation forms of the scientific frequency shows that beyond to global to they forms determined by the oscillation monster is seen in the image which shows the type of forms 8 and 13 agent frequencies. In the image graph, the response depends of the values of global nature frequency with tense on the support, which shows that the frequency take a value in the operation range and the frequency a certain character get into it. Therefore, this factor will have strong impact on the structural reliability on the studied model of failure. Table 1 shows the on the table shows the values of the failure probability, mathematical exponentials, variance, and the frequency gradient. For the global natural frequency of the operation when varying the values of stiffness support in the operation range. The operation frequency range will still equal to operation range. This is a fair probability of the frequency age in the operation range. The natural form of this frequency is calculated by the joint deformations of bending and torsion of the structure as a whole. So, to change the value of these frequencies requires calculations of the entire structure. Conclusions. Mathematical models for solving the problem of natural chances and reliability of the turbine unit are formulated considering random imperfections. Geometrical and computational model building are completed. A series of natural frequency calculations and form for the of the system for which comparisons with the experimental data are performed. The natural frequencies in spectrum with high sensitivity to rigidity of the foundations of forms which are characterized by the global reformation of the whole system are determined. Reliability characteristics are determined, which show the probability to get in the denominator of frequency in separation. This can lead to incident in the system under study. Additional research is needed to determine effective measure to prevent them. Thank you very much for your attention.
Dear Sirs, let me introduce a report about influence of horizontal inertial loads on the operation of overhead crane girders. Introduction and major challenges. This report deals with the issue related to bridge-type cranes with pre-stressed spans. Such cranes are used to a limited extent in industry. It should be noted that cranes with pre-stressed span girders have considerably less weight owing to less moment of inertia of beam section that positively influence on many other parameters, improving operational conditions of the machine and is a significant advantage. At the same time, such span beams are more deformable, which can lead to structural failure or malfunction. They have significantly less weight and smaller dimensions compared to conventional cranes, as well as a lower cost of the crane's metal structure, which can be from 75 to 80% of the cost of the crane as a whole. Note that the operation of cranes with pre-stressed beams occur under the same conditions operating models and the same lifting capacities as usual, for which the calculation in the design of the crane bridge is carried out in accordance with the established design combination of loads A, plane XOY, and B, plane XOZ. This, during the operation of a pre-stressed crane bridge in conditions of oblique bending, the bridge must be provided with high strength and rigidity in two planes, in the main vertical plane XOY and in the horizontal plane XOZ. These conditions must be taken into account in matters related to the calculation and design of cranes with pre-stressed bridges. It requires additional research in relation to the real operating conditions of the crane. In these connections, the issues related to the calculation and design of such structures require special attention and study and very relevant aim and research tasks. The research aim is to further study the stress-strain state of a pre-stressed main beam operating simultaneously in two planes. Research tasks: to develop a mathematical model of a pre-stressed crane bridge taking into account the work of the main beam in the horizontal and vertical planes. To investigate and analyze the obtained results. Research methodology. When developing the mathematical model in accordance with the requirements put forward for the crane bridge operation, we notice that it's necessary to consider two types of bridge design diagrams. The first of the load combination A and the second for the load combination B. When compiling design diagrams, we assume that all elements of the crane are solid. The beam operates in the elastic stage and rests on ideal handles. Let us introduce the notation U and K1. The expression of the curve of the crane bridge deflection and bending moments in the XOY plane will be calculated by expression. The expression for deflection curve of the crane bridge Y and the moments bending in the XOY plane M will have the form presented here, and the scheme of the calculation scheme is placed on this slide too. Results. Calculation scheme of the bridge for the load combination B. With the combination of loads B on the pre-stressed crane bridge X in the plane XOZ, horizontal inertial loads Fu determined by the masses of the bridge MM, car MT, cargo M, and acceleration gamma. The expression is here. The Design diagram of the span beam when it works in the horizontal plane is shown below. After simple transformation, we obtain the corresponding expression for the beam deflection arrow. This expression. We get the bending moment by differentiating the last expression twice, expression M. According to obtained expressions for combination of loads A and B, mathematical research of the formatted state of the beam with a span of I equal 10, deformations of the bridge are presented in the form of the beam deflection here. Conditional deflection of the main beam. With the ratio of forces acting on the beam F divided to 1.5, the use of pre-stressing gives a possibility to minimize the deflection of the span. The conditional deflections of the beam, main beam, is shown in the table at the right. Deformations of the bridge in the planes XOY and XOZ is shown on the next slide. Deformations of the bridge. On the left, there are deformations of the bridge in the plane XOY, and on the right there are deformations of the bridge in the planes XOY, XOZ. Conclusion. When the eccentric compressive force is applied, the deflection of the beam can be reduced by from 50 to 70%, which has a positive effect on the deformated state of the span bridge. For the combination of loads B, an increase in the magnitude of compressive forces leads to a significant increase of deformation in the horizontal plane. The ratio of forces F divided to 1.5 can be acceptable for the crane bridge. At the same time, the beam deformations at oblique bending exceed the limit of deflection from temporary load of the usual bridge without unloading devices. The results obtained in this work can also be used in the future for modernization in order to increase their carrying capacity, increase the service life without dismantling, as well as to improve existing structure and engineering calculation methods during design in real operation conditions. Thank you very much for your attention.
Hello, my name is Elena Avdieva. I'm from Kharkiv Polytechnical Institute. Today I'm going to speak about supersonic flow in the blade channel of the nozzle with the rotary diaphragm at small degrees of opening. Continuous development and improvement of design and operating modes of district heating turbines has led to the use of steam with highly critical parameters. At the moment, one of the promising areas of development of district heating turbines is the work on the critical pressure drops, increasing the parameters of the steam entails an increase in flow velocity in the intercap flow channels of the nozzle and working channels. It is necessary to repurpose the flow part to obtain the optimal geometric shape with the lowest coefficients of loss of kinetic energy. Development of methods for optimizing the flow part of district heating turbines is an urgent task. A future of district heating turbines that regulate steam extraction. With the use of nozzle gratings with rotating diaphragm, the change in steam flow growth, the turbine in variable modes is achieved by overlapping at the inlet the channels of the nozzle shown is the left part of the slide. The part of the nozzles, the blocks, the inlet channel is called the rotor diaphragm. The structure of the flow in the channel of the nozzle. This is greatly influenced by the degree of opening of the diaphragm. Delta here, delta is the rate of the area of covered rotor diaphragm to the area of the fully open diaphragm in the process of development. A method for the numerical study of the flat flow of the nozzle teeth with the rotating diaphragm calculations were performed at different degrees of opening of the rotary diaphragm delta and pressure drops P on the lattice is the result for small degrees of opening of a rotary diaphragm. Difficult pictures of the current in the interscapular channel of the nozzle's device were received. For a more detailed study of these statements, it was decided to conduct an additional numerous studies. Having research task, the aim of the work in the numerical study, the supersonic the nozzle channel at the degree of opening of the rotary diaphragm, research task, construction of computational grids, a choice of turbulence model of numerical study, comparison of flow patterns for 2D and 3D simulations, confirmation of the phenomena for other profiles, and to opening direction, description of the process occurring in the interscapular canal research methodology. They calculate the use the model of two-dimensional flow of viscous gas sieve dissolver fluid was used using a different method. For the second order, the working fluid is viscous of compressible gas air as a boundary conditions for entry into this settlement area were used. Breaking parameters pressure and temperature, direction of air flow, intensity of turbulence, hydraulic diameter. The ultimate condition for leaving the calculation area was set by air pressure. The calculated area is one interscapular channel, the formed back and the cinnamon profile. See 9013P. The profile is presented on the left side on this slide. The calculation area presented in the right part of the slide can be divided into two parts, movable limited rotary diaphragm and stationary limited interscapular channel for rotary diaphragm. In this regard, you can once build separate grids for these areas and then using a non-conformant interface move them relative to another, simulating different degrees of opening delta on the diaphragm. In practice, due to the need to seal the grid in the walls to meet the Y+1 size requirements, a poorly matched and distorted interface is obtained. Test calculations showed the presence of gaps and jumps on the lines of the parameters, which forced to abandon the use of non-conforming interface mixed for the calculated area of each of the selected stages of opening the rotor diaphragm built its own network. Since the position in the channel and behind it jumps are compacted, the separation of flows and so on is not known, that the grid was built to provide Y+1 conditions in the wall area. As a result, the number of grid elements range from 1.8 to 2.4, 10 power 5, depending on the degree of discovery. Delta part of the grid in the area of the rotor diaphragm for two-dimensional calculations is presented on the left side of the slide. To calculate the spatial flow modeling of the interscapular channel of the nozzle efforts with the degree of opening of the diaphragm, delta 0.3 was performed. The height of the channel was 80 millimeters in the computational domain of constructing a grid from polyhexagonal elements. Part of the grid in the area of the rotor diaphragm for three-dimensional calculations is presented in the right part of this slide. At the first stage, to assess the impact of the used turbulence model on the result of calculations, very general calculations were performed in which the simulation of turbulent phenomena alternately simulated the turbulence of car omega system and Reynolds fluency of dissolved stress. The slide presents a picture of the flow obtained by calculating using the Reynolds turbulence model stress, as can be seen from the figure of the nature of the flow in the interscapular canal is similar to the previously obtained from pattern calculated using the omega system turbulence model. For the further calculations, the turbulence model omega system was chosen. Numerous studies of the spatial flow in the interscapular canal, since the main task was to confirm the previously obtained picture in the interscapular canal presented in the left part of the slide without calculating the coefficient of loss of kinetic energy, so that the calculated area was divided into a small number of elements, more than 8 million. All settings of the solver are the same as the simulation of flat flow. The turbulence model omega system was used as a picture of the current in the plane at a height of 40 millimeters is presented in the right part of the slide. In all cases, a picture of the flow in the interscapular canal with the separation of the flow nucleus in the supersonic region was obtained. In order to determine the magnitude of the relative pressure drop on the nozzle apparatus in which the curve of the flow is removed by shock fronts on individual areas, additional calculations are performed at the relative pressure drops on the nozzle grid P 0.5, 0.45, 0.4, 0.35, 0.3. As a result of the calculations, it was found that for the degree of openness delta 0.3, tau 0.66, separation of the flow of region by shock fronts in the region begins at a relative difference P 0.4 left side of this slide. Some sources state that in order to reduce the length of the determined attachment zone with partial open diaphragm, the rotary ring should be moved to the closing position, unlike the traditional method used in turbulence in the direction from the concave throat to the convex surface back of the nozzle channel and in the opening position in the opposite direction. A numerical study was performed to determine the coefficient of loss of kinetic energy with a degree of openness delta 0.3 and the position of the moving part of the rotor diaphragm as described above. The picture of a flow in the interscapular canal of the nozzle apparatus at P 0.3. Studies have shown an increase in kinetic energy losses relative to the traditional direction of movement of the rotor diaphragm. This slide shows the beat is a lines of Mach number for the investigated lattice profile at P 0.3 and delta 0.3 and the distribution of static pressure in the interscapular canal. Since of the condition of equality of input and output costs must be met so that in diffuse flow the channel is a local increase in velocity in the flow occur to compensate for the reduction of the passage section due to the overlap of the rotor diaphragm. As can be seen, the static pressure at the outlet of the channel is greater than at the entrance to the channel. To have a flow motion, it occurs against a positive pressure gradient. Thus, the interscapular channel is divided into two areas at a cinnamon of shovel area or supersonic current at the back area of vortex subsonic current. This is confirmed by the distribution of Mach numbers and the position of the region with a critical difference in the interscapular canal. Conclusions. This slide shows the conclusions. Thank you very much for your attention.
Good day, dear participants of the conference. My name is Tatiana. Let me to present you the results of our research on the theme mathematical model of lifting particles of technological material by vertical orgy. The vertical orgy, which rotates inside the coaxial cylindrical casing, is widely used for transportation of technological material. To improve the constructive and technological parameters of this process, it's necessary to have analytical dependencies that describe the interaction of particles of technological material with the working bodies. The interaction of particles with each other is quite difficult to take into account. So it's common to consider the transportation of a single particle. The obtained patterns can be transferred to the material. In the case of the moving surface of the working body, the motion of the particle consists of two components: the relative motion of the particle sliding on the surface and the portable, for example, rotational motion of the surface itself. The relative motion of a particle is considered relatively to a moving coordinate system. The sum of these motions will give the absolute trajectory along which the particle moves in a fixed coordinate system. In mechanics, during solving problems of the dynamics of a material point, the equations of equilibrium of applied forces in projections on the axis of the spatial coordinate system, which can be fixed or movable, should be compiled. In our case, such a system is a moving coordinate system, which in differential geometry is called the accompanying Frenet rhehedron of the guide curve. The motion of a rhehedron along a guide curve is a portable motion, and the motion of a point in a system of a rhehedron is relative. So, the aim of our research was to apply movable rhehedron and Frenet formulas to analytically describe the complex motion of a material point on the periphery of a vertical orgy that rotates inside a coaxial cylindrical casing. The rhehedron is formed by three mutually perpendicular unit orbs and moves with a given velocity along the flat guide curve. On this slide, you can see the mathematical base of our research. Allow me not to consider it in details and move on to its application to analytical description of the process of transportation the particle by a vertical orgy which rotates around its axis inside the cylindrical casing. When the particle hits the orgy, it begins to slide on it, moving away from the axis because of the centrifugal force. On the left figure, the sliding trajectory is shown by a dashed line. At the moment of contact with the cylindrical casing, the particle begins to interact with both surfaces. At the same time, it's forced to slide along the helical line, the edge of the orgy, with a constant angle of rising. If the orgy rotates at a given angular velocity counterclockwise, the particle will slide in a helical line in the opposite direction and at the same time should rise upwards. Therefore, the sliding of the particle regarding the orgy is clockwise and the rise is provided by the appropriate direction of winding of the orgy. On the right picture, the applied to the particle forces are shown. When the orgy rotates, the helical line, its edge, rotates too, and a particle slides along it. Let the guide curve for a rhehedron be another circle with a constant curvature. When the rhehedron is moving along the guide circle, point B must slide along the helical line. To combine these movements, it's necessary to set the given dependence, where S is the length of the arc of the guide circle. The shape of the absolute trajectory of point B depends on it. It will have a special shape and will not satisfy the requirements of the Auger functioning, in which absolute trajectory does not leave the surface of the cylinder. According to the requirement of the Auger functioning, both circles must be equal during lifting along the helical line. The particle must rotate clockwise and the top of the trihedron must move in a circle. These requirements are satisfied by the following parametrical equations of the helical line in the trihedron system. It's obvious that at a given angle of rising of the helical line, the periphery of the Auger, the angular velocity of its rotation will not be enough to lift the particle. It's possible that it sticks, so rotates with the Auger without sliding on it. In this case, in relative motion, it's stationary, and in absolute describes a circle on the inner surface of the cylindrical casing. The given equation makes it possible to find out under what conditions this occurs. If the Auger is rotated with such angular velocity, there is no moment of the particle in the vertical direction. It can be seen from the graph on the left side, which was constructed by numerical method. For the accepted parameters of the cylindrical casing and the angle of rising of the edge of the Auger 15 degrees, according to the formula, the value of the angular velocity 14.2 seconds to the minus first power was obtained. Graphic shows that at 15 degrees the velocity in the vertical direction is equal to 0. However, at an angle minus 15 degrees, the velocity increases and over time becomes constant, but the particle does not move up but down. This means that the winding direction of the Auger has changed to the opposite and the particle slides in the opposite side to the direction of its rotation and moves down. When the angle increases to 20 degrees, the particle moves down regardless of its sign. Thus, at angles greater than the limit value 15 degrees, the particle cannot move upwards at a constant angular velocity of rotation of the Auger. At smaller value, the particle moves up and at a change in the sign of the angle, down. The graphs show that in all cases the velocity of the particle becomes constant over time. On the other two figures, relative trajectories of the particle movement at different values of the angle beta are presented by thin lines and absolute trajectories by secant lines. So, Frenet formulas were used in compiling the analytical dependencies of particle motion. As a result of the numerical solution of the equations, it was found that the velocity of particle rising is influenced by constructive and technological parameters. In particular, for a given radius of the cylindrical casing, friction coefficients, and the angle of rising of the edge of the Auger, there is a minimum value of the angular velocity of its rotation. The particle in this case sticks and rotates together with the Auger, describing in absolute motion a circle on the inner surface of the cylindrical casing. The obtained results allow the construction of geometrical form of working bodies of machines according to the final necessary conditions. Thank you for attention. Analytical dependencies of particle motion. As a result of the numerical solution of the equations, it was found that the velocity of particle rising is influenced by constructive and technological parameters. In particular, for a given radius of the cylindrical casing, friction coefficients, and the angle of rising of the edge of the Auger, there is a minimum value of the angular velocity of its rotation. The particle in this case sticks and rotates together with the order, describing in absolute motion a circle on the inner surface of the cylindrical casing. The obtained results allow the construction of geometrical form of working bodies of machines according to the final necessary conditions. Thank you for attention.
If you've sent to me, or some verbal questions, please. So I suppose that Konstantin is online, and he can answer something. I would like to ask if to the colleagues, if there are some questions about the second paper, about the rotor dynamics and stability study. There are some questions, please. Of course, I would like to put you a question, Anton, if possible. I have seen that your work is very interesting, as others that were presented here. But when comparing your work with other similar ones, I suppose that you have performed this task. Which are the main advantages of your study? inclined cylinder rotating around the axis. And it was a very detailed study. I liked very much because it is supported by a very nice theoretical background. I would like to ask if some colleagues or some author of the paper? Okay. So I think that if there are some questions, you
Sergey
can
is
contact
absent,
Sergey or other authors for putting questions by email, for instance.
Sergey is absent in the chat.
Sorry, I was not listening.
Listen me.
But Sergey is there? No.
Jose, this is Vitaly Ivanov. Do you hear me?
Yes?
Sergey is absent because he is in the region that under war attacks.
Okay.
Due to technical reasons, he cannot connect.
Okay, good. So let's move to the next presentation, please. So the presentation, influence of horizontal natural loads on the operation of overhead crane girders. So it was presented by Alexander Fomin. So there are some questions for Alexander. Alexander, are you there, right? Yes, he's there. So there are some questions. Okay, I have one question. Alexander, I have seen. Because I see your name, but I cannot hear you. Perhaps there are technical problems, right?
Let's move to the next session.
Okay.
Next speaker.
Okay, so the next presentation is from Olena. She's not there also because I've been informed about this. And finally, the last one, but not least, Tatiana, again, with the mathematical model of lifting particles of technological material by vertical auger. So if there are some questions, please, Tatiana. So Tatiana, this work is again very nice work with very good. It will be my pleasure. Thank you very much.
Thank you very much. finished. After the technical break, we will start the session number 6.
Включай заставку.
Сейчас выпуск в эфир не идет? Сейчас. Не, надо, чтобы не шел. Словами, how are you?
Lepochenko. I am a professor of the Department of Chemical Engineering and Vice Dean for IT of the Faculty of Technical System Management and Efficient Technology of Sumy State University. It's a great honor for me to be a session chair and to represent the next session 6, our conference, Chemical Process Technology. In this session we have 8 presentations, 7 video presentations from 3 speakers who is here and waiting online for the question and answer session. Attention, we have time limit, 5 minutes for presentation and 2-3 minutes for questions, answer and in discussion. Sorry, Saif Hussein, we will shorten your presentation to 8 minutes. The first presentation topic is design and modernization of circuit for fuel oil heating and tar cooling. The speaker is Gennady Khavin. The second presentation topic, design of reactors with mechanical mixers and biodiesel production. The speaker is Mikhailo Mushruk. Third presentation, purification of oil field wastewater and bayonet cell methods. The speaker is Hussein Seif. The fourth presentation, application of low frequency mechanical vibration for development of high efficient continuous extraction equipment. The speaker is Professor Vladimir Zavyalov. The fifth presentation topic, research of wet fiber with pumping fraction plant additive. The speaker is Maria Zheplinska. The next presentation topic, comparative evaluation of the contact elements efficiency for barium sulfide solution carbonization. The speaker is Musi Tseitlin, professor. The next presentation topic, justification of vibroventric external load during mechanical processing of glycerin containing products. The speaker is Igor Polomarchuk. And the last presentation topic, hydraulic resistance and spray transfer in stabilization 3-phase foam layer. The speaker is Khalif Rybko. Our speakers represent National Technical University, Kharkiv Polytechnic Institute, National University of Life and Environment Science of Ukraine, National University of Food Technology, Sumy State University, National University National University of Food Technologies, Poltav State Agrarium Academy, Bukovina State Medical University, State Institution, State Research and Design Institute of Basic Chemistry, Vinnytsia Institute of Trade and Economics of Kyiv National University of Trade and Economics. That's all from Ukraine, and Al Hayat company for sale from Kuwait. Thank you for attention.
Good afternoon. Our research team are grateful for the chance to take part in the conference and present our findings. So let me start with introduction and major challenges.
Good morning, dear colleagues. My name is Gennady Havin. I am a professor of National Technical University, Kharkov Polytechnical Institute. I want to inform you about the solution of the practical problem, which was born from the need to build a small oil refinery. This problem is related to energy recovery, and its peculiarity is to use some heat exchanger equipment that already is available. The oil and gas preparation and oil refining process include several stages, many of which use heat exchangers. Equipment designed for this industry must meet special requirements to be able to operate at extreme pressures and temperatures, to be resistant to aggressive media, to have compact dimensions, and to work with two-phase media. Currently, the use of compact heat exchangers in the preparation and processing of petroleum products take place mainly in small industries. Their installation for continuous vacuum distillation of fuel oil with a capacity of 100 to 300 tons per day for the raw materials. The main advantages of this application are the simplicity of logistics, the possibility of using plate and collapsible heat exchanger equipment, the use of new technological solutions, reducing environmental pollution, etc. The oil and gas preparation and oil refinery process includes several stages, many of which use heat exchangers. Equipment designed for this industry must meet special requirements to be able to operate the extreme pressure and temperatures, to be resistant to aggressive media, to have compact dimensions, and to work with two-phase media. Currently, the use of compact heat exchangers in the preparation and processing of petroleum products take place mainly in small industries. The installation for continuous vacuum distillation of fuel oil with a capacity of 100 to 300 tons per day for raw materials. The main advantages of these applications are the simplicity of logistics, the possibility of using plate and collapsible heat exchangers equipment, the use of new technological solutions, reducing environmental pollution, etc. The main goal of the study is to achieve the assigned task of heating fuel oil by using the available heat exchanger equipment and by redistributing the flows. The limitation in this obligatory use of two cross-flow heat exchangers of the compact block type and two spiral heat exchangers with given surfaces of heat transfer. In this case, the flow rates, temperatures, and pressure drops indicated in the formulation of the problem are rigidly fixed, but the possibility of installing a additional heat exchanger equipment is allowed. To implement the project, several of its constituent particular tasks were solved, including designing a new thermal scheme and calculation of new heat exchanger equipment. In general case, the problem was formulated as follows. Some oil stream must be heated from 90 degrees to 293 degrees by a tar stream, which is divided at the outlet into a cooled tar stream and quencher at the temperature of 278 degrees. At the preliminary design stage, it is supposed to use 4 heat exchangers that already available for this. The thermophysical properties of heat carriers were determined and calculated in several ways. Combo block is a welded cross-flow apparatus with a collapsible body structure. The design of combo block is based on a package of laser-welded in pairs corrugated metal plates which form channels. Each model has its own standard set of inserts to meet the most varied technological requirements. Combo block frame consists of 4 corner posts, top and bottom plate, and 4 side plates with ports. The entire structure is bolted together and can be quickly disassembled for inspection or cleaning. Panels and ports can be coated or even made entirely of same materials as plates. Size of nozzle is determined by frame width, plate size, frame height, number of plates, and number of plates per stroke for multi-pass heat exchangers. Differences of nozzle size as well as flexibility of the multi-port layout make the combo block suitable for fluid-to-liquid systems with different characteristics. When combo block is used as the condenser, the steam inlet must have diameter larger than outlet. Heat exchangers of this type are indispensable for working with media that tend to form deposits on heat transfer surfaces. The design of spiral heat exchangers provides the effect of self-cleaning of heat transfer channels. At the same time, there is still a possibility of traditional mechanical cleaning and flushing. The main parameter of units pressure, temperature up to 400 degrees, mass flow rate up to 100 kg per second. Heat transfer surface area to 300 square meters. Heat transfer coefficient close to 2,000-3,000 watt meter square degree. Spiral heat exchangers are used as condensers, reboilers, and coolers heaters for media liquid-liquid, gas-liquid, gas plus steam, liquid, gas-gas. The most common spiral heat exchangers are of 2 types, which have design features. During vapor-liquid heat exchanger, the structure is characterized by a protruding upper cover, which communicates with the open ends of the heating carrier channel and condensate drainages on the lower cover. In the case of liquid-liquid heat exchangers, the connecting pipes are located axially on the cylindrical surface of the apparatus wall. As a result of the design and study of the heat exchangers operation system as a whole, a basic thermal scheme for solving the problem was proposed. It is shown on figure. During the design process, it was defined that the solution of the task using available 4 heat exchangers is impossible. Therefore, it was decided to install an additional intermediate unit. A spiral heat exchanger of the same brand was chosen as an additional heat exchanger, and his parameters are given in table. The working surface of the heat exchanger unit is 128 square meter, and total surface is 139 square meters. The reserve of the working surface for the expected contamination is at 10%. As a result, the thermal scheme with 5 heat exchangers was obtained. This scheme satisfies the condition of the formulated problem both in terms of heat transfer parameters and pressure drop hydraulic resistance. Thus, the posed and formulated problem was solved by installing additional heat exchangers. Design conditions are met. Thank you very much for your attention. Have a nice day. Goodbye.
Михайло Муштрук, Лариса Баль-Прилипко, Наталія Слободянюк, and Mykola Nikolaenko from National University of Life and Environmental Sciences of Ukraine, and by Yuri Boyko from National University of Food Technology, Ukraine. The title of the presentation is The Design of Reactors with Mechanical Mixers in Biodiesel Production. Introduction and Major Challenges. The energy crisis has affected almost all countries of the world, and it has not bypassed Ukraine. Therefore, alternative energy sources are being actively introduced. Production of diesel biofuel by esterification and transesterification is promising and affordable. The purpose of alcohol analysis of lipid raw materials is to obtain diesel biofuel and reduce the viscosity to a level close to the mineral diesel fuel and ensure compliance with applicable standards. The main factors influencing the reaction rate and the degree of conversion of lipid raw materials into fuel are the molar ratio of alcohol and fat, the type of catalyst and its concentration, temperature and reaction time, the level of the FFA, and water in the fat stock. Diesel biofuel production uses mostly refined vegetable oils, which consist mainly of triglycerides and contain little FFA. Such refined oils, for example soybean and rapeseed, have a high cost, which is about 60 to 80% of the total fuel cost. In this regard, biofuels produced from such oils are not commercially competitive in the market compared to the mineral diesel. About 200,000 tons of animal fats are accumulated annually at the meat processing enterprises of Ukraine alone, and if we take into consideration the plants for the production of meat and bone meal, it is about 100,000 tons. If the world economy, commercial production of diesel biofuel from technical animal fats, or TFA, was widespread, and to date scientists are intensely reacting and researching to this issue, and they're actually researching the processing of lipid raw materials, which has the lowest possible cost to reduce the cost of biofuel production and increase its competitiveness in the energy market. Such raw materials as brew have a high acid number, contain water and protein impurities, which requires in-depth research, design, and development of new technologies and equipment for the production of diesel biofuels. Therefore, technological processes and their rational hardware implementation for processing fats, for example, into diesel biofuels, can be created only based on detailed study of physiochemical, mechanics of basics and auxiliary materials involved in the process. Only on this basis it is possible to create basic high-performance equipment that provides not only high fuel yield, but also compliance with current domestic and foreign standards. Aim and research tasks. The purpose of research is to substantiate the method of designing reactors for the production of diesel biofuels from fats or vegetable and animal origin. Research tasks are to analyze the processes and designs of equipment for the conversion of fats into diesel biofuels. They are also to substantiate the rational design and technological parameters of the batch reactor for the production of diesel biofuels. It is also to determine the design features of the reactor, taking into account the need for mixing reagents without standard zones, ensuring unimpeded deposition of glycerol phase and periodic draining of intermediate and final products. And the last research task is to develop a mathematical model of the process of production of diesel biofuels, and on this basis to develop a design algorithm and a rational design of the reactor and means of mechanization of mixing of reagents to ensure high yield and fuel quality. Research methodology. Modern theoretical concepts of physical and mathematical modeling of viscous and liquid media, similarity theory, fundamental laws of hydrodynamics, numerical method, which includes mathematical model, sampling method, numerical grid, final approximation, and solution method were used in theoretical research. Mathematically modeled technological process of conversion of TAF in the production of diesel biofuel and batch reactor, taking into account the physiochemical mechanics of raw materials, reagents, and determined rational design and technological parameters of batch reactor with a two-stage turbine mixer. A method for calculating the field of mixing rates of reagents in reactors with mechanical turbine stirrers, which consists of the numerical solution of the system of differential equations of conservation of mass and momentum with partial derivatives in cylindrical coordinates in the three-dimensional formulation. In reactors with high-speed turbine stirrers, two characteristic regions can be distinguished. The first region, adjacent to the stirrer, is characterized by a large velocity gradient, and the region extends to the walls of the apparatus. The requirement for the convergence of the solution is necessary and needs to be investigated. It requires the grid pitch in the area adjacent to the mixer that was less than 3 millimeters. Outside, it was less than 8 millimeters. Based on the conducted research and the recommendations following from scientific words of processors and considering features of the technological process of production of diesel biofuel, the scheme of designing of reactors of periodic action for biofuel production is developed. As a result of the research, the methods of the multiple reference system, MROS, and computational snapshot were used, in which an imaginary cylindrical zone with a radius greater than the radius of the mixer and less than the inner radius of the edges of the baffle plates, and a sufficient height, including the entire mixer, divides apparatus into two regions. These methods required the detailing of the mixing device. Attempts have also been made to model using large eddy models, LES. However, the computational requirements for this model are large, and therefore the application of this method is limited to relatively simple forms of mixing devices. Also, this model has not been sufficiently tested to assert the adequacy of the results obtained. Experimental research used equipment from the manufacturer Robotron model systems to assess the kinematic and energy characteristics of the production process and the physical and mechanical properties of the final product of biodiesel. Results. We are presenting you a method of calculating the field of mixing rates of reagents in reactions with mechanical turbine stirrers, which consist of the numerical solution of the system of different equations of conservation of mass and momentum with partial derivatives in cylindrical coordinates in three-dimension formulation, about which we talked in the previous slides. In Figure 2 shows the experimental and calculated values of the power criterion depending on the centrifugal Reynolds number RET for a reactor with an open turbine stirrer and 4 baffles with a width of B. D is the reactor diameter divided by 12, which shows that the difference between them does not exceed 8%. For the same reactor, the power criterion was determined for different diameters of the stirrer. As a result, it turned out that with an increase in the diameter of the stirrer 2 times, the power criterion increased by 1.5 times, which is seen on Figure 3. The choice of mixing method and type of stirrer is determined by the intended purpose and scientific conditions of the process. Therefore, when choosing a stirrer, use the approximate characteristics of the conditions of the appropriate use of different types of stirrers. After analyzing the results of theoretical and experimental studies, an open turbine mixer was chosen, because when using it, the yield of biofuel was 92 to 95%. The kinematic viscosity of the reaction mixture during the reaction was the lowest complete phase separation, and it was completed in 20 to 25 minutes. Figure 4 shows the distribution of flow velocities in 3 of 7 considered devices with stirrers with a diameter of 0.264 d, and the distances between them is 1 divided by 2.5 d. At a distance between the stirrers C1 to 2 equals dm, the combined flow structure is realized, and at C1 to 2 it equals 2.5 dm. The parallel structure of the reagent flow is realized. When the distance between the stirrers is greater than the diameter of the stirrers, the interaction between the flows of the upper and lower stirrers weakens and leads to the division of the reactor volume into 2 equal symmetrical parts in height. It can also be noted that with increasing distance between the stirrers, more circulating circuits are formed. The maximum value of the rate of dissipation of kinetic energy determines in the intensity of mixing of the components of the reaction mixture and the micro level, which ensures the occurrence of their small-scale shear deformations, as a consequence, obtaining finely dispersed emulsions and suspensions. The analysis of the distribution of the kinetic energy dissipation rate is the 7 considered devices allowed us to conclude that increasing the distance between the stirrers leads to an increase in the kinetic energy dissipation rate, which is apparent on Figure 5, and the C1 to 2 equals 1.7 dm. Its limits value is reached. It is also necessary to take into the consideration the fact that an increase in the rate of energy dissipation can be achieved with small diameters of stirrers, as can be seen from Figure number 6. However, it should be remembered that in the increase in C1 to 2 leads to the formation of weakly interacting flows, which leads to an appearance of Stegen zones, and thus these effects should be considered in the complex. Other parameters of the reactor depend on some specific design solutions. The given algorithm And the scheme of the design technically allows us to carry out calculations of the basic design parameters of reactors of any productivity of the mechanical mixers of any type. Conclusions. By this paper, it is established that the charge of diametric simplicities of dm divided by d, c1 to 2 divided by dm, or cd to 2 divided by d, and cm to k divided by dm leads to completely divided velocity fields in reactions with steering devices on which such important characteristics are the power or the criterion depend, and the rate of dissipation of kinetic energy as well. It is established that the power criteria, or within reactor 1 or 2, stage turbine stirrers depend on the simplex of C to 1 to 2 divided by dm, and have the form of symmetric function with S-like shape, sigmoid. An analysis of the distribution of the kinetic energy dissipation in 7 simulated reactors was performed in order to identify areas with maximum values of this value for the correct selection of the zone of introduction of alcohol catalytic fluid solution into the reactor. The analysis of the distribution of the kinetic energy dissipation rate in the 7 considered devices allowed us to conclude that increasing the distance between the stirrers leads to an increase of the kinetic energy dissipation rate, and at C-1 equals 1.7 dm, its limits value is reached, which allows to determine the coordinates catalytic fluid solution. The multiple reference frame method looks promising as a tool for simulating agitators, as it can be expected to mixers of various shapes, to units with multi-triggered agitators, when simulating multi-phase flows without excessive demands on computational resources, and, most importantly, it is available in many SFD complexes. Thank you very much for your attention. We thank Mihailo Mushtruk from National University of Life and Environmental Sciences of Ukraine, Faculty of Food, Technology and Quality Control of Agricultural Products, Department of Process and Equipment for Processing of Agricultural Production, that is located at the Heroes of Defense Street, number 12B in Kyiv, Ukraine. Please reach out using the following email if you have any questions or concerns regarding this presentation. And again, thank you very much for your attention.
Good day, everyone. Today, our presentation about purification of oil field wastewater by internal methods. The creation and developing of technology and installation for the treatment of oil field wastewater, OFW, for disposal in oil reservoir flooding systems is an actual problem. Wastewater contaminate with emulsified petroleum products and solid suspended soil is often formed during the production process. Currently, about 90% of oil is extracted from field using oil reservoir flooding methods to maintain formation pressure. Oil field wastewater has a suspension emulsion character, belongs to mineralized, polydispersed, microheterogenic systems. The properties of oil field wastewater, OFW, especially the state of the armor shell on the droplets of the dispersed phase of oil determine the method of destruction purification of oil field water for a certain time. The purification of OFW for the purpose of flooding of productive horizons consists in the removal of oil and mechanical impurities from them to the specified industrial standard. Utilization of purified OFW in oil formation flooding system is an economical and environmental beneficial way to eliminate them in the oil field. During the development of oil field, there is a change in the parameters and properties of the extracted fluid, the properties of reservoir water, productive formations, residual oil reserves. The technical and technological condition of oil field equipment including apparatuses and, in general, wastewater treatment plants. This factor determined the need for modernization, improvement, reconstruction of flooding system, including OFW purification system. This slide, aim and research tasks. The current scheme of pumping wastewater back into reservoir at oil field with the addition of reagent to increase oil recovery leads to a significant change in the chemical composition of reservoir waters, which affects the state of the subsurface and also create a threat of spreading pollution to other aquifers. In solving this problem, one of the main tasks is to purify oil containing reservoir wastewater in order to achieve stable characteristics of the natural environment with acceptable to purify oil-containing reservoir wastewater in order to achieve stable characteristics of the natural environment with acceptable parameters of contamination, as well as possible extraction of valuable commodity components from recycled water. After oil treatment plant, oil field wastewater is pre-treated from oil and mechanical impurities and it's pumped into the oil reservoir without disturbing its pickup rate through injection well. Up to now, the biggest problem in the oil and gas industry remains the treatment of reservoir water and oil field wastewater. Their disposal is an urgent problem for all production facilities of the oil and gas industry. The relevance is due to the fact that reservoir water as an aggressive component causes intense corrosion of oil production equipment, accompanied by the spillage of reservoir water, causing salinization of the soil cover and groundwater during seepage and the death of vegetation. As a result of a reservoir water spill, a certain amount of oil is also received along the way, which can amount to tens of tons per year. Reservoir water have many toxic components in their composition. Research methodology, the problem of developing layer theory. This approach helps to determine the effectiveness of hydrocyclones with minimal involvement of experimental data. Thank you very much for your attention.
Dear colleagues, good afternoon. I am glad to see you. My name is Vladimir Zavyalov. I am representative National University Food Technology, Department of Processes and Apparatus of Food Production. Dear colleagues, today our team conduct research in the direction of purposeful identification of technological process. One of such direction is the scientific substantiation of vibration extraction process in the solid-liquid system. So the topic of my reports, application of low-frequency mechanical vibration for development of highly efficient continuous extraction equipment. Today, the development of industry under new economic conditions is characterized by the development of complex systems with the aim to use rationally vegetable raw materials and to process them to largest depth, and by the introduction of waste-free and energy-saving technologies. For the most material-intensive food industries such as sugar, oil, food, canning, wine, pharmaceutical industry, and other, in which 1 million tons of raw materials of vegetable, root, fruit, and berry origin are annually processed, these problems are particularly urgent. What are the problems here? As a rule, vegetable raw materials or their mass prepared for extraction do not have a sufficiently high natural porosity for efficient counterflow extraction, are transported bodily and can be densified. As a result, the practical problem of providing conditions for the optimal realization of the extraction process by traditional method is difficult. One of the most efficient methods of the intensification for the extraction process consists in using intensive hydrodynamic regimes. Vibratory extraction are the most promising. Vibratory extraction is a relatively new technological process. Its general theory is complex and still in its early stage of development. Hydrodynamic studies were performed on the vibration extractor model shown in Fig 1, with the body from organic glass with a diameter of 0.3 meter and height of 1.5 meter on system of nylon crab water. Amplitude of oscillation varied within up to 15 millimeters and frequency before 10 Hz. A plant material is fed through the loading device under the bottom plate under the influence of vibration plate and due to the difference of hydraulic resistance of the nozzles move upward counter-current extractant which is fed upper plate and is discharged through the device. On this picture, we can see the stream transport separation plate. On this poster shows the algorithm of large scale transition of turbulent pulsating jet of vibroextraction process. On this poster we can see determination of velocities of pulsating turbulent flow. To determine the velocity of pulsating jet used or a pitot plant tube as shown in Fig 1, position B. According to the readings of differential pressure judge the average integral for the period of oscillation and average cross section velocity of pulsating flow on the remote L of the measuring tube from the middle position of the plate were calculated. Question 1. The determined value of WL was attributed to the initial average integral for the period of oscillation of the pulsating flow velocity. Question 2. The distance L was determined by analogy with stationary turbulence jet. Question 3. Next poster, a present experimental data for the nozzle with a diameter of 15 millimeters installed in a branch pipe with a diameter 65 on 45 millimeters. This course represents attentionally of the relative velocity of pulsating flow. The line shows the universal profile of the relative velocity in the cross section of a stationary turbulent jet calculated by the Schlichting. Question 4. It is established that the experimental data mainly correspond to the universal profile of relative velocity in the cross-section of turbulent jets calculated by the Schlichting equation. As a result, we propose a formula to establish the ratio 5. This poster shows a chain of fluid pulsating jet of the half-life of vibration during vibro extraction, and this L range of jet spreading. The range L is the main initial value when calculated the hydrodynamic situation in the device. In this functional spatio-temporal coordinates Fig 5, the enterdate area was generalized at theta phi less than the critical volume, the equation 6. By the now Schlichting formula for the universal velocity profile in a distance turbulent transit, the question 7. As can be seen from the graphical depends shown in Fig 5, the experimental data in the new coordinate system obtained for the pulsating jet generated by the transport elements of vibratory mixing device are grouped around the curves of the universal hydrodynamic profile of a turbulent stationary fluid jet. The point K, we can see in this graph, is the limit to which there is almost complete coincidence with the universal profile, and after it deviation occurs at considerable distance from the source of pulsating jet. Having determined all the bases of depends WL divided W0 on L experimental volume L phi, it is possible to locate L distance and V WL necessary at decisioning of vibro extractor. Thus, the possibility of using fundamental regulated for calculate the hydrodynamics of turbulent jet, the ensured efficient operation of vibro extractor is established. The obtained scaling result were used in the decision of industrial vibro extractor of continuous action for processing of plant raw materials and its waste by the company TMA in Kyiv. We can see vibro extractor in this picture. On this poster we can see brief conclusion for the report. Thank you very much for your attention.
Марія Жеплінська, Володимир Васильєв, Олена Дев'ятко, Сергій Ульянко from National University of Life and Environmental Sciences of Ukraine, and Natalia Kanivets from Poltava State Agrarian Academy, Ukraine, presenting you a presentation titled Research of Wheat Fiber with Pumpkin Pectin Plant Additive for Use in the Meat Industry. Introduction and Major Challenges. Nowadays, a promising direction in providing the population with high-quality food products of increased nutritional and biological value in the combination of raw materials of plant and animal origin, considering adequate human needs according to the modern nutritional requirements. Innovative approaches to solving the problem of nutrition consist of creating products with increased nutritional value which is one of the priority areas for solving problems highlighted in the concept of the state policy and product quality management. The socioeconomic problem of the shortage, high cost, and low quality of food, including meat products in Ukraine, is particularly critical. In recent years, there have been specific changes in the lives of people, a significant decrease in physical activity, the change in healthy eating habits, and the change of consumers' needs. Considering this, some of the previously declared features of sausages do not correspond to the current demand, for example, high calorie content, which does not attract but requires adjustments instead. Aim and research tasks. The research aim is to study the planned supplement of wheat fiber with pumpkin pectin and replace it with a certain amount of meat to enrich the nutrients in ready-made sausages. Research tasks are to investigate the fractional composition of wheat fiber and those particles with pumpkin pectin. It also aims to study the effect of the degree of grinding of wheat fiber with pumpkin pectin on the duration of the process and functional properties. The next research task is to determine the rational modern of preliminary preparation of plant additives in combination with minced meat of the optimal hydromodule. And the last research task is to prove the advantages of improving the technology of sausage production, in particular improving their consumer qualities and the prospects of using herbal supplement to increase their nutritional value. Research methodology. The raw materials and materials used in research complied with the current regulations in Ukraine in terms of quality and safety approved for use by the Ministry of Health of Ukraine. The following raw materials were used for research: the beef first grade, muscle tissue with mass fraction of connective and adipose tissue not more than 6%, lean pork semi-fat, muscle tissue with mass fraction of adipose tissue from 50 to 85%. Wheat fiber with pumpkin pectin in the composition of 20% of pumpkin pectin and 80% of crushed shell of wheat grain. Multi-component minced meat, which includes lean semi-fat pork, beef, and grade, plant additive in different ratios of 3, 5, and 7% respectively. Ready-cooked sausage with vegetable additive. The experimental studies included 3 stages. At the first stage, a study of physiochemical parameters of PFWPP, which means pectin fiber with pumpkin pectin, supplement, amino acid composition of its protein, mineral, and vitamin, were calculated. Based on the obtained indicators, the energy value and coefficients were presumed. Protein water, fat water, food saturation, potential biological value, difference in amino acids, utilization of amino acid composition of protein, and indicator of excess content and index of essential amino acids. The safety of raw materials was assessed by microbiological parameters, content of heavy metals, pesticides, insecticides, pesticides, herbicides, and content of mycotoxin or botulin and radionuclides. The safety of raw materials was assessed by microbiological parameters, content of heavy metals, pesticides, which we mentioned before, and content of the mycotoxin. At the second stage, the development and substitution of the technology of cooked sausages was carried out, which included the determining of the features of the preliminary preparation of vegetable additives for the introduction of cooked sausages into the minced meat system, and the time of grinding to a homogeneous state. Study of the hydraulic module and the ratio of crushed vegetable additives before the formulation of cooked sausages. Substitution of the prescription composition of cooked sausages with the addition of PFWPP and the method of its introduction into the minced meat. And the last one is assessment of structural, mechanical, and organoleptic indicators of cooked sausages with the use of vegetable additive PFWPP and changes into the indicators during storage. Results. The study of combining a dried plant additive into the model minced meat showed that an expediency of its use and its form because of the proper formulation of the structure of the cooked sausage did not occur. The shape and particle size of dry wheat fiber with pumpkin pectin have a heterogeneous composition. By shape, the particles are divided into three groups: arrow-shaped, rod-shaped, and spherical. By size, we found particles with sizes of 1,000 to 700 meters, and 600 to 500, and 400 to 100. The fractional composition of wheat fiber with pumpkin pectin is presented in Table 1. The analysis of these data shows that the particles of 600 to 500 have the largest mass fraction of wheat fiber with pumpkin pectin, which equals 45% of particles. Of 400 to 100 have the smaller mass fraction, which equals to 15%, and particles of 1,000 to 700 have the mass fraction of 40%. A meat shop universe drive PM 1.1 with a set of replaceable grinding mechanism was used for fine grinding of wheat fiber with pumpkin pectin. The degree of grinding of the wheat fiber with pumpkin pectin depends on the strength, hardness, and ultrastructure of the plant additive and the time of grinding. Studies have shown that after 3 to 4 minutes of grinding, wheat fiber with pumpkin pectin has a homogeneous structure with a grain size of 5 to 600. The longer grinding time of wheat fiber with pumpkin pectin leads to its transformation into sticky flour state. High homogenization of the additive results in the adhesive interaction of its particle, and technological problem of the separation of individual fraction arises. The resulting crushed mixture of plants additive was sieved in the sieve with a magnetic metal contamination trap. As a result, the obtained plant additive looked like a uniform color powder of free-flowing consistency with pleasant taste and smell. During the manufacture of cooked sausages, and the properties that, to a greater extent, provide organoleptic and structural properties of these products. Such properties include indicators of water binding, water holding, and fat holding properties. Previous research has shown that one factor affecting these functional properties is the grinding degree of plant additives. The results of studies on the dependence of the functional parameters of wheat fiber with pumpkin pectin on the degree of its grinding are presented in Table 2. The results of studies indicate that particles with a size of 600 micrometer have the largest water holding, water binding, and fat holding capacities. The water binding capacity of the plant additive depending on the time of water absorption and different ratios of additive and water is shown in Figure 3. While analyzing the data for Figure 3, we can see that for all of the hydromodules, the water binding capacity of plant supplement grows gradually as the time increases up to 15 minutes. The best water binding capacity of wheat fiber with pumpkin pectin was reached at hydromodule 3. After keeping the plant additive in water for 15 minutes, the water binding capacity decreases at the hydromodules used in the experiment. It is important to consider the rhetorical properties of the ingredients, effective viscosity, and shear stress when creating new recipes for cooked sausages. The study of these properties enables the technological process of making cooked sausages with specified organoleptic properties. It is known that these properties depend on the chemical composition of hydromodules. Table 3 presents the data on the chemical composition of wheat fiber with pumpkin pectin at different plant additive to water ratios. It is found that the increase in moisture leads to a corresponding decrease in dry matter content, for example, protein from 15.01 to 7.82, fat from 3.0 to 1.78% of ash, from hydromodule 1 to 5. Obviously, the change of the chemical composition will result in a change of functional and technological properties. Therefore, a study of the two dependencies of the effective viscosity, shear force of the ratio of plant additives to water was conducted. By this study, it was established that the hydration of the combined plant additive was insufficient and the additive was dry in hydromodule 1 and 2, and the additive has a dense consistency which was suitable for combining with minced meat for the cooked sausages at hydromodule 3. With an increase of the hydromodule to more than 4, a liquid consistency of the additive was formed, resulting in decrease of the effective viscosity value. It has been determined that the structural and mechanical properties of a compact coagulation system change depending on the proportion of the dispersion medium in the system and the presence or absence of stabilizing component. At low shear stress, they act like elastic bodies. At high stresses, they get the ability to flow. When the shear stress is higher than the conditional yield point, that conditional plastic body is capable of irreversible deformations, and a rather slow flow with a plastic body is capable of irreversible deformation. It can be concluded from Figure 4 that the complex plant additive has a high effective viscosity due to the high water binding capacity at certain parameters of the hydromodule. Obviously, the structure and the mechanical properties of the plant additive can be attributed to compact, solid congelation structures. Conclusions. The fractional composition of the additive wheat fiber with pumpkin pectin was studied, the largest mass fraction of which was the particles with sizes 600 to 500 nanometers of 45%, the smallest particle with sizes 400 to 100, and the rest particles with sizes 1000 to 700. The influence of the plant additive grinding degree on the functional indicators is presented, which shows that the particles with the size of 600 have the best indicators of water holding, water binding, and fat holding capacities. The rational mode of preliminary preparation of plant additive for combining with minced meat with the hydration of hydromodule 3 is determined. This stage of the technological process provides the highest rate of water holding capacity, and 1:3 ratio of plant additive to refined oil provides the high rate of fat holding. The benefit of improving the technology of sausages has been determined, particularly increasing their consumer qualities and the prospects of using plant additives to improve their nutritional value. It is proved that the wheat fiber with pumpkin pectin has all the necessary proteins to be recommended as the plant additive in the technology of cooked sausages in order to improve the functional, technological, and organoleptic properties. Well, thank you very much for your attention. With any questions, please reach out using the following email, which belongs to Maria Zaplinska from National University of Life and Environmental Sciences of Ukraine, Faculty of Food Technology and Quality Control of Agricultural Products, Department of Processes and Equipment for Processing of Agricultural Production, that is located on Heroes of Defense Street, number 12B in Kiev, Ukraine. We thank you again very much for your attention.
Dear colleagues, your attention is invited to abstracts on the topic Justification of the type of vibroventrentic external load in the process of mechanical pressing of glycerin-containing products. Traditionally, in the food and processing industry, convective drying technologies are widely used, implemented in a variety of design dryers, shaft, belt, drum, in which the heat transfer to the raw material is carried out using a drying agent through the outer shell of the product to the inner layers. A detailed analysis of the most common technologies of convective drying shows that drying equipment in terms of energy intensity, environmental regulations and product safety do not meet modern requirements. Traditional approaches to drying technology are faced with an insurmountable contradiction. On the one hand, to intensify the processes of heat and mass transfer, it is required to increase the speed of the drying agent. Therefore, with increasing coolant consumption, the amount of heat lost by the installation increases and vice versa. It seems that the way out for the solution of the indicated contradiction is connected with the change of the principles of energy supply to the product. All determine the driving forces that may have a diverse nature. Currently, new, promising types of equipment have been created. the effectiveness of which is difficult to explain from the standpoint of the modern theory of drying. Therefore, the dehydration technique develops faster than the theoretical substantiation of the new principles of moisture removal. The driving forces of these processes do not correspond to the diffusion principles. Often, dehydration is a complex of combined processes involving processes that require correct consideration of the actual mechanisms of moisture transfer. It seems that the problems arising from the description of the drying process are explained by the fact that the authors, supporters of the phenomenological approach, consider drying as a kind of one process with constant transfer coefficients and form models from these assumptions. In this paper, it is hypothesized that drying is the result of the action on the principle of superposition of at least three processes: moisture transfer from the surface of a solid, moisture transfer in constrained capillary conditions, and moisture desorption. Each of these processes is characterized by the value of the driving force and the kinetic coefficient of the speed of the process. The aim of this research is evaluation of the effectiveness and justification of the method for determining the driving force of mechanical dehydration of glycerin-containing raw materials due to the comparative analysis and determination of the driving force of centrifugal, planetary, vibration, and vibrational planetary actions. Research tasks are: conduct a comparative analysis of centrifugal, vibrational, planetary, and combined vibration planetary technological actions in terms of the intensity of the created force field. Choose a schematic diagram and an experimental model of the installation for the combined vibration planetary dehydration of glycerin-containing raw materials, and evaluate the patterns of change of pressure created in the working zone from the kinetic characteristics of the investigated technical systems. The raw materials and materials used in the research complied with the current regulations in Ukraine in terms of quality and safety, approved for use by the Ministry of Health of Ukraine. The following raw materials were used for research: lean beef first grade, muscle tissue with a mass fraction of connective and adipose tissue not more than 6%. Lean pork semi-fat, muscle tissue with a mass fraction of adipose tissue from 50 to 85%, wheat fiber with pumpkin pectin in the composition. 20% of pumpkin pectin and 80% crushed shell of wheat grain, multi-component minced meat, which includes lean semi-fat pork, beef and grade, plant additive in different ratios. Ready cooked sausage with vegetable additive. The experimental studies included 3 stages. At the first stage, a study of physiochemical parameters of pectin fiber with pumpkin pectin supplement, amino acid composition of its proteins, mineral and vitamin composition. Based on the obtained indicators, the energy value and coefficients were calculated: protein water, fat water, food saturation, potential biological value, difference of amino acid, utilitarianism of amino acid composition of protein, indicator of excess content and index of essential amino acids. The safety of raw materials was assessed by microbiological parameters: content of heavy metals, pesticides, insecticides, herbicides, content of mycotoxin, patulin, and radionuclides. The laboratory of the National University Life and Environmental Sciences of Ukraine has developed a set of equipment for the mechanical dehydration of food and processing industries, which are characterized by either vibratory, or centrifugal, or planetary technological effects, or their combination. with centrifugal effects. The growth of the driving force of the process is determined by the design parameters of the working bodies and the angular velocity of their rotation. Vibration action allows, due to alternating accelerations in the contact zone, to significantly increase the intensity of the force field. The planetary model of the movement of the working bodies due to the peculiarities of the mechanism kinematics makes it possible to significantly increase the potential of the mechanical effect on the processed products. To evaluate the presented characteristics, an experimental model of a vibroplanetary machine for pressing the mass of the load in oppositely located containers was designed and manufactured. Performing such permutations on one installation indicates the purity of the experiment. Processing of the obtained dependencies for the specified parameters of the studied processes was performed using graph analytical analysis in the mathematical environment MathCAD. A distinctive feature of this machine is the ability of the working drum to simultaneously rotate around its axis, the central axis, and perform vibrations in the horizontal plane. In addition, in the installation, there is the possibility of independent regulation of the angular velocities of rotation of the container and carrier, which allows choosing its operation modes within wide limits. To determine the dynamic characteristics of the dehydrated products in a vibration planetary machine, let's consider the scheme shown in Figure 2. Figure 3 shows a graph of the resulting pressure as a function of the ratio of the angular velocities of rotation of the working capacity and the carrier. The graph shows the increase in pressure from increasing specified angular velocities. The increase in pressure depending on the degree of drum loading is shown in the left figure. From changes in the angular velocity of carrier rotation in the center figure, and from the change in the angular velocity of container rotation in the right figure, as can be seen from the graphs, as obtained from research. The effect of vibration has a significant effect on a number of indicators. The pressure decreases with increasing load, with increasing angular velocity of the carrier, and with increasing angular velocity of the container. As a result of our research, let's make some conclusions. Effective technological schemes for the implementation of dehydration of elastic plastic products are presented, or such evaluation criteria is performance, energy, and material costs. Damage to the feedstock. A schematic diagram and an experimental model of a vibration planetary machine for dehydration of glycerin-containing products. In which a combination of the above power factors of influence is implemented, are developed. The pressure occurring inside the drum, which makes a vibration planetary motion, is determined. Graphic dependencies of the influence of the kinematic characteristics of the investigated technical systems on the driving force of these processes are obtained, which display increase in pressure on the processing load with an increase in the angular velocities of the carrier and the working drum, influence of the vibration component on the pressure inside the drum, which decreases when the angular velocity increases, alignment of the influence of the vibration component at the level of 10–11% with an increase in the angular velocity of the container. Thank you for your attention. For all your questions, please contact us at the addresses listed below. Have a good day.
hydraulic resistance and spray transfer in a stabilized 3-phase form layer. Introduction and major challenges. In modern conditions of significant anthropogenetic impact on the environment, the search of the most effective and economical methods of cleaning industrial emissions is relevant. Cleaning methods and development equipment should take into account the possibility of working in a wide range of operating conditions. Reduce energy compression in system of capturing harmful and toxic substrates. It is necessary to reduce hydraulic resistance while maintaining high effectively in cleaning gas flow. Aim and research tasks. Give the contractor requirements of equipment and distinct the large number of exciting devices for mass transfer process. The development of new high-intensive and effective equipment is of considerable intensity of environmental technology of main industries. Common methods of clean gas streams is absorption. Methods of absorbing harmful components of exhaust industrial gases. In this case, enter the process of physical absorption octus, or the absorption enters into chemical interaction with the absorbent component, and the way to investigate those processes is to carry out them in a stabilized 3-phase form layer. Previous studied the devices with a form layer were used many technological cycles with difficult physical loads on gas and liquid. This is led to high energy compression. At the same time, in a system of cleaning industrial gases from harmful components with usually present in low contaminations, it is necessary to ensure a high degree of gas purification with minimal liquid compression and low separate ratio. Research technology. Research methodology. For those proposed a new degrees of stabilization with a large free volume and multiple spherical noises was dependent. The advanced of the proposed design is transporting to the structured form mode of operating at relevant low gas speeds, as well as development interspace contact surface. The cellular structures of the stabilizer and movable noise make it possible to achieve increased volumes of mass transfer coefficients due to the effect of film formation in small cells. The structure has high possibility and violently low hydraulic resistance. The structure may have different ability dependent on the therapy of material. The new decisions are simple and have relevantly low cost, with always them to be effectively used in the process of gas cleaning in an environment in industries. The combined contact blocks consist. The combined block consists of a hollow plate and one or two contact elements acting as stabilizers, and a movable ball charged noise located inside the block. The boom layer is formed on the hollow plates on this movable noise is located. In this work, the hydraulic resistance of the proposed design and spray transfer indicator were studied. Schematic pictures of an experimental equipment set for studying hydrodynamics is shown on slide 7. The experimental units consist of the following main elements: a vertical column unit with compressed combined contact blocks, a fan flow, water supply, water distribution, and catchment system, a combined contact unit with movable balls shaped noises is started in the middle working section of the column. Separator and water distribution systems are placed in the upper section of the column, and the lower section is designed to the enter airflow through the windows located into the full air supply and water collector. Contribution fast moved is organized in the column. Air from the fan is fed through the flow to the lower part of the unit. Then it passes through the mesh distributed as a result of which a uniform speed profile is achieved. The entrances to the contact unit. The liquid fast from the pressure tank is fed into the column for irrigation. For uniform T1 distribution of the liquid shower over the cross section of the device. A distributor is installed on top. Passing through the device, the liquid is distributed over the surface of the contact elements, and the gas first occupies the entry-free volume of the device. Then the liquid enters the storage tank, and the air released into the atmosphere. 3 component contact blocks were installed in the column. The middle block is working. Result. In thing 2 is shown the dependence of the hydraulic resistance of a dry contact element on the gas velocity in the free cross-section of the column, then using whole plates of different 3 cross-section in the pressure of the mobile noise, and without it. From thing 2, it can be seen that as the gas velocity increases, the hydraulic resistance increased. The similar, the free cross of whole plates and the diameter of the holes in the plates leads to the great hydraulic dynamic resistance. The hydraulic resistance of the foam layer board is used to judge not only the energy speed of the process, but the intensity of the process as whole, since the head of the foam and its hydraulic resistance are interrelated. Analyzing the operating recurrences, we can say that hydraulic resistance is most affected by the gas velocity is the full cross-section of the device, and the free cross-section is confined in thing 3. So it can be seen that with increased velocity, the hydraulic resistance of the contact elements increases. This is due to the fact that as the gas velocity increases, the height of the gas liquid layer increases with a significant level in equilibrium, which leads to a proportional increases in resistance. The hydraulic resistance and 3 cross-section of the contact elements have environment relationships. With an increase of the 3 cross-section, the hydraulic resistance describes science the foam, weight, and holding capacity of the contact stage described, and at low gas speeds, the liquid fluid on the lower contact page increases. Spray transfers in the combined contact elements with multiple noise. One of the most important characters One of the most important characters of colonial apartments is slash transfer. Dating studies at the gas velocity from 2 to 4 meters per second. Modes of a highly turbulent gas-liquid system were observed, and the phenomenon of slash transfer present. Experiments of slash removed and spray transfer were carried out depending on the number of parameters affecting the 3-phase gas liquid form layer mode. Those included the gas velocity, the liquid load, the free cross-section of the contact stage and the holest diameters of the whole blades. From the info, we can see that the large holes in the blade, the greater the splash transfer volume. This fact is explained by increasing the diameter of the holes, kinetic force increases. This forms larger gaseous volumes. As a result, the kinetic energy of the foam layer increases and droplets and spray transfer with a not completely resistant even by double stabilization of the foam layer. Without this significantly reduces splash more compared to the operation of a whole blade without stabilization of the flow layer. The gas velocity in the free cross section has a necessary effect on the spray transfer. After installing the second stabilization in the upper part of the foam layer, a significant reduction in splashes was observed. Since the gaseous liquid flow has a diagonal division and the direction of gas and liquid at an angle to the wall of the device. When the irradiation density increases, there was a significant decrease in the amount to spray transfer. After experimental studies of the hydrodynamic characters of the combined contact elements with mobile noise, experimental data on hydrodynamic resistance, and experimental encounters of spray transfer are attributed for the contact stage with combined contact elements with mobile noise were observed. The main purpose of the first stabilizer located in the bulbous zone is the the appearance of lockdown pulsation of the gas liquid layer at higher layer volumes of the gas velocity in the full cross section of the device. Due to the presence of the contact elements in the pulsation zone of the gas liquid layer, the device creates a full stage of parts. The use of such a designing of the stabilizer does not significantly increase the hydraulic resistance of the device due to large free volume. The installation of the second stabilizer void, the first helps to reduce splash transfer from the contact zone, and the subtrain logical mixing of phases, which generally improves the mass transfer process in the device. The spool of the converter and angle to the horizontal effective route for liquid drop failing zone under the arm wing. Placed in the space between the whole blade and the first stabilizer of the ball movable zone contributors to the construct upping of the fast contact surface in the specific zone. The design of the mobile zone has a pyramid structure. To do is generally procedure the foam layer, and the small volume of the gas velocity in the column noises spaces into a spaced state and the activity to place the system in a regular space. As a result of research, it found that using foam layer stabilizers, the spray transfer ratio at the contact stage is reduced with layers to more stable and uniform operation of the device. Empirical dependence of the volume of the spray transfer operation are given. Those for future intensification of certain apparatus, it is possible to use proposed design using a free-sharp form layer with movable noise. Previously, it was standard that the use managed materials of the manufacture of noisy bodies is missing, and then it necessary to hazard the perfectly of the operation of device with such noisy type. In apparatus with movable balls, noisable gas space between the channels folder, but noisy balls and liquid in the form of these films and drops flow down the surface for the balls. In the case of managed nozzle, the interaction of gas with liquid occurs not only the surface of the
Okay, thank you for all speakers. Thank you for very interesting speeches and presentations. And we start question and answer session. The first presentation Professor Haven is absent. Да. Okay. The next presentation from Professor Mushruk. I have questions. The topic of your speech is design of reactors with mechanical mixers in biodiesel production, but you did not show the engineering design algorithm. Is there such a typical standard method of calculation and design for engineers? Can you explain the algorithm for calculation the transcentrifugation reactor in this production? Please, dear Mikhailo.
Rhythm of production reactor from other article. This article we not have.
Okay. Thank you. Thank you. Dear participants, today is the 106th day of the war and Russian invasion of Ukraine. Now Ukrainian soldiers are judged to protect us. Professor Tsetlin, Professor Zavyalov was forced to leave the Kiev, Kharkov in February, and he is still in evacuation. There are no internet and mobile communication. We apologize, maybe he will find a way to contact us soon, and you can read his publication in conference procession. Thank you for your attention and understanding. Let's get ready to save Ukrainian together. Other speakers are absent too. Sorry. Dear participants, now the session 6, Chemical Process Technology, is fully completed. We had time for lunch, and then, according to the schedule, we will start next session, session 8, Energy Efficient Technologies. Thank you for all. Good luck.
Thank you very much. Good luck too.
Co to jest?
Co?
No to!
To? A, to! Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Co to jest?
Co?
No to!
To? A, to. Przycisk do papieru. Zbudowałem wczoraj.
Ale to trzyma pranie.
No.
We'll teach you how to build robots, and you do what you like with it. Faculty of Mechanical Engineering, Poznan University of Technology. You create your own future. Mechanical Engineering, for those who want to know how things work and how they are made. Mechatronics, for those who want to bring mechanics to life. Biomedical Engineering, for those who want to develop modern technologies in medicine. Production Management and Engineering, for those who want to be leaders and managers of production processes. Join us and start creating the future. Faculty of Mechanical Engineering, Poznan University of Technology.
Znajdujemy się w laboratorium modelowania inteligentnych systemów produkcyjnych. To jest laboratorium, które zagląda w przyszłość. Myśmy przenieśli część przemysłu na Politechnikę. Dzięki temu możemy realizować prace badawcze i eksperymentalne, tak jakbyśmy je robili w środowisku przemysłowym. Jeżeli chodzi o oprogramowanie, w dużej mierze jest to przyszłość, która też jest przedmiotem zainteresowania firm software'owych. Jesteśmy w stanie przeprowadzać szkolenia związane z wybranymi obszarami automatyzacji bądź przemysłu 4.0 i to jest ten ważny element, który staramy się wykorzystać również w tych działaniach związanych z zarówno współpracą pomiędzy uczelniami, jak i współpracą z przemysłem.
Ты мне скажи, когда ты запускаешь?
Ты должен ее показать правильно, где истинная Трояновская, да?
Юлия Тарасевич.
Такая, ты финская?
Ну, Юлия Тарасевич уже вот в онлайне, она уже ждет начала секции.
Она к нам не подключилась.
Вот она в WebEx, я ее вижу.
Вот это она?
Да, это Юлия.
А, я понял, ну надо.
Ну, неважно, да.
Надо, значит.
А это вы, да. Мы еще узнаем. Мы сейчас готовимся буквально 30 секунд и запускаем стрим. Ты мне скажи, Саш, когда?
Хорошо.
Виктор Александрович, привет, дорогой. Виталий Александрович.
Добрый день. Добрый день, Николай Иванович. Сейчас Да, я в Сумах. Секундочку, мы сейчас запускаем трансляцию. Давайте чуть
Сергею Михайловичу привет и закрываю.
Обязательно, обязательно. Мы практически готовы. Сейчас буквально минута. Буквально минута, и мы начинаем. Скажи, начинаем, и мы начнем. Починаємо. Юлія Ярославна, можемо починати?
Hello, dear colleagues. My name is Dmitro Konovalov. I'm from Admiral Makarov National University of Shipbuilding, and I would like to present some results of scientific work of development of gas dynamic cooling system for gas turbine over expansion circuit. A topical direction for increasing the efficiency of gas turbine plant is using of energy-saving technology that will ensure the low-grade heat utilization from secondary energy sources and compensate for the negative impact of ambient temperature on the fuel and energy efficiency of gas turbine plants. One of the ways to increase the efficiency of a gas turbine is additional expansion of combustion products below atmospheric pressure in an auxiliary turbine installed after the main power turbine. That is the use of an overexpansion turbine. The power received in the overexpansion turbine is spent on pressing the exhaust gases to atmospheric pressure by the compressor. Excess power can be transferred to mechanical or electrical energy. The main objectives of the study are to develop methods for cooling the gas turbine exhaust gases in overexpansion circuit with a simultaneous increase in pressure, that is using thermodynamic compression, determine the rational parameters of the process of dynamic cooling of gas turbine plant exhaust gases in the overexpansion circuit using a thermopressor, which ensures the maximum increase in the capacity of the overexpansion turbine and accordingly the maximum increase in the gas turbine plant power as a whole. As a result, a reduction in specific fuel consumption to develop diagrams of gas dynamic cooling system for gas turbine plant of gases in an overexpansion circuit using a thermopressor. In modern ship power engineering processes are widely used in which the movement of the gas channels occurs under various influences, a change in the flow area of a channel and energy exchange with the environment and by heat transfer friction against the channel walls, change in gas flow due to the supply of liquid into the flow, a complex mechanical process and thermal interaction of liquid droplets with a gas stream. With intensive heat removal and reorganization of the working process, it becomes possible to increase the total pressure of the gas flow. In this case, its compression occurs due to the prevailing thermal effect, heat removal, in comparison with the pressure loss due to the friction. The device in which the increase in the total gas pressure occurs due to the removal of heat from is called a thermopressor. Heat removal from the gas flow can be carried out by heat transfer through the channel walls, non-contact method, or in the process of evaporation of the injected liquid into the gas flow, contact or evaporative cooling, moving at speed of sound. The thermopressor is a fairly compact device that combines the function of gas compression and deep cooling. Therefore, it's obvious to use it in the overexpansion loop of a gas turbine unit as a compressor and cooler at the same time. Research method parameters of gas turbine plant exhaust gases and the process of gas dynamic cooling in the thermopressor were calculated accordingly to the developed method and programmed using the equations of the thermodynamic and gas dynamic of the flow. The cycle and parameters of the gas turbine were calculated according to the classical method and the developed software package based on them. A diagram of the gas turbine additional circuit with an overexpansion turbine and the gas turbine plant cycle are shown in this picture. In this slide, the gas cooler in the circuit can be replaced with a compact thermopressor. In the nozzle of the thermopressor, the gas expands adiabatically to an even low pressure and is polytropically compressed in the diffuser of the apparatus. In this case, the total gas consumption increases by an amount equal to the amount of the water injected into the thermopressor. It can be seen that the compressor operation decreases due to a decrease in the compression ratio and therefore leads to an increase in the thermal efficiency of the gas turbine plant cycle. Then the gas is polytropically compressed in the compressor to a pressure equal to atmospheric pressure. The operation of the thermopressor gas turbine circuit as a part of the UGT 2500 gas turbine produced by Zarya project Ukraine was analyzed. The result of calculating the thermopressor as part of the gas turbine overexpansion circuit show that the gas temperature through the overexpansion turbine at the inlet to the thermopressor is 300 to 400 degrees. When a large temperature difference in the gas is triggered in the thermopressor, it's possible to obtain a significant increase in pressure. So, at the gas temperature at the turbine inlet overexpansion is 450 degrees. The relative increase in gas pressure is 10 to 35%. It can be seen, and a temperature difference over the gas in the thermopressor of more than 300 degrees, the gas turbine plant can operate without a compressor at all, since the thermopressor is able to increase the gas pressure above atmospheric. The calculation results show the possibility of increasing the useful power by 23%. For the UGT 2500, the additional steam consumption for the desalination plant is 16 to 17 kilograms per second. Therefore, it's advisable to use such a scheme in the presence of fresh water sources that don't require additional costs for its production. Alternatively, can be offered a combined plant scheme with a thermopressor installed after the compressor. The gas after the overexpansion turbine is cooled in a cooler and compressed in a compressor to a pressure of no higher than 900 kilopascals. This scheme allows to reduce the flow rate of water injected into the thermopressor to 5%. The operation of the thermopressure circuit as part of the following low-power gas turbine plants was analyzed for the Ramash project Ukraine, Capstone Turbine Corporation USA, and Toyota Turbine System Japan. The use of an overexpansion turbine reduces the gas temperature at the gas turbine plant outlet by 50 to 60 degrees. However, the thermal potential of waste gases for use in a thermopressor is quite large, is 450 to 480 degrees. When the temperature difference in the gas is triggered in the thermopressor from the temperature at the inlet to 50 degrees at the thermopressor outlet, it's possible to obtain a significant increase in pressure. The pressure increase in the thermopressor is 32 to 36%. The rather large pressure drop is explained by the large temperature drop in the thermopressor, which is 350 to 430 degrees. It makes it possible to increase the expansion ratio of the turbine with a corresponding increase. The turbine power is 60 to 100 kilowatts. The temperature is 15 to 20 degrees. It can be seen that the power value is maximum, which is explained by the opposite behavior of the values on which the turbine power depends. The flow rate of waste gases decreases with increasing inlet temperature, and the temperature increases with the corresponding increase in pressure in the thermopressor. Additional power of the overexpansion turbine increases the gas turbine plant's total power. In comparison with the basis of one is 10 to 20%. It can be concluded that the use of the thermopressor in the conjunction with an overexpansion turbine is more effectively at low gas turbine plant capacities, since turbines of this type correspond to higher gas outlet temperatures, and hence to higher value of increase in pressure. So, conclusions. The use of combustion products energy in the gas turbine plants by overexpansion below atmospheric pressure in an additional overexpansion turbine, which is installed after the main turbine with a subsequent increase in pressure in the thermopressor, provides an increase in the gas turbine plant capacity by 2 to 3%. Due to the use of the thermopressor, it's possible to operate the gas turbine plant without an additional compressor, but the temperature of the exhaust gases must be at least 300 degrees. The use of thermopressor compression make it possible to combine several functions in one apparatus, thermopressor at once, compression or compressor, and cooling or gas cooler, which in turn make it possible to apply gas overexpansion in gas turbines on specialized or hovercraft, where the installation of additional equipment is problematic due to the limited space of the engine room. So, thank you very much for your attention.
Good day, dear colleagues. I presented my paper, Reduction of Granular Materials Losses in a Vortex Chamber Supercharger Drainage Channel. Bulk cargoes pumping in hydraulic and pneumatic transport is accompanied by high wear of the blowers and pumps with a low reliability and durability of hydro-pneumatic transport systems. Ways to increase the durability of such systems are practically exhausted due to the limited choice of wear-resistant materials and improvements of the pump's vane system. Increasing the reliability and durability of systems must be done with a simultaneous solution to the problem of increasing energy saving indicators and reliability. The solution to the problems of the blower's reliability can be the use of jet superchargers, but low efficiency indicators prevent the widespread use of direct flow water and two-phase ejectors. The use of centrifugal force has made it possible to create more efficient devices for pumping granular materials, vortex chamber supercharger. Its efficiency when it pumps a bulk medium with air is more than twice as high as efficiency of classical jet pumps. However, the working process of such a blower is implemented with the release of a part of the pumped medium through the drainage channel, which creates significant inconveniences in its use. One of the main disadvantages of vortex chamber superchargers is the presence of the pumped medium in the axial drainage channel, which reduces the operational efficiency and the supercharger use in hydropneumatic systems. Thus, the aim of this paper is to reduce granular materials losses in the vortex chamber supercharger drainage channel. The construction of the vortex device considered in present study. The vortex chamber supercharger is a vortex mixing chamber and 4 channels, 2 axial channels and 2 tangential ones. The primary flow, water or air, is supplied through the tangential inlet channel and creates a swirling flow inside the chamber with characteristic hydrodynamic flow features. Gauge pressure at the periphery of the vortex chamber and vacuum near the axis. The near-axis vacuum is used to create a differential pressure that facilitates the pumping process. The granular materials enters through the inlet axial channel to the vortex chamber, acquires kinetic energy and also moves to the vortex chamber periphery under the centrifugal force influence. The gauge pressure magnitude at the periphery of the vortex chamber depends on how the second axial channel is used. It is possible to implement 2 different work processes depending on the geometric ratio of the tangential and axial channels. The first working process is characterized by relatively high pressure at the periphery and a relatively lower outlet mass flow rate. The second, on the contrary, is a higher flow rate at relatively low pressure at the vortex chamber outlet. This paper is devoted to modeling the movement of solid particle in vortex chamber supercharger and studying the loss flow rate in the drainage channel during the implementation of a working process with the drainage channel. Obviously, the second working process without the drainage channel makes it possible to completely reduce the losses of the pumped granular materials to zero and change the drainage channel function to the suction channel. But in this case, the pressure at the blower periphery is significantly reduced. Numerical modeling of processes in various devices has been actively developed recently, including vortex chamber pumps. CFD computational fluid dynamics could track each solid particle pumped by the pump and determine the efficiency of its operation. Since the concentration of solid particles in the supercharger is low, it would be appropriate to use the Lagrange approach. According to this approach, the trajectories of each particle are calculated taking into account the influence on the main liquid or gas flow. For these purposes, a three-dimensional model is built. A mesh and the calculation is performed based on numerical methods. The study was carried out in three stages. First, it's a mathematical modeling of the fluid flow in the supercharger was carried out with the interaction between solid particle based on the calculation of Reynolds average at Navier-Stokes system of equation. Since the simulation of the flow led to a vacuum error near the axis, a rotation curvature correction was included. In the second stage, an experimental study of the shifting of bulk cargos was carried out and the flow rate of material losses in the supercharger drainage channel was measured. In this study, only the drag force was considered for a significant reduction in the calculation time, considering the particles' affection the gas flow. The flow patterns of the gas and solid phases are shown in the slide. Comparison of the gas flow into the blower with and without solid particles shows that the particle concentration is not sufficient for a serious effect of particle on the flow characteristics. The main parameters of supercharger remain independent of solid particles presence. The distribution of solid particles by diameter shows the instantaneous arrangement of particles in the meridional and horizontal planes. The distribution of particles qualitatively confirms the adequacy of mathematical model and corresponds to the instantaneous flow patterns observed in the experiment. As a result of the calculation, the mass flow rates of solid particles passing through the boundary condition were determined, which made it possible to compare the mass flow rates with the experiment. By means of particle trajectories mathematical modeling in the supercharger, it was possible to determine the mass flow rate of losses of the pumped medium. The flow rate was determined by calculating the number of particles entering the drainage channel in relation to the total amount of solid particles. The simulation results were verified by experimental studies. Reducing losses allows for improved industrial design and efficiency of supercharger applications. Increasing the primary flow dynamic pressure leads to a decrease in the losses in the drainage channel. At a dynamic pressures of more than 5,000 pascals, the simulation results were in very good agreement with the experiment. There are minimal losses of the secondary flow as if the density of solid particle density is 2,000 till 3,000 kg per cubic meter. Density values with minimal flow rate ratio of losses are explained by the peculiarities of energy transfer to the pumped particle. With an increase in density, the particle does not have time to gain speed and begin to rotate near the vortex chamber axis, which leads to the fact that the particle falls into the drainage channel. The decrease in losses can be increase in the vortex chamber height or the setting of a rotary motion to a particle in the inlet hopper. The increase in the vortex chamber height can worsen the energy characteristics of the blower operation and its efficiency. Therefore, it's more promising to create rotational flow at the chamber inlet, for example, using a vane swirler. Thank you very much for your attention. My report is finished, and I'm waiting for your questions, and I will be glad to answer your question, please.
Good afternoon, everyone. My name is Tatiana Rodimchenko. I work at Sumy State University. I am an engineer, and now I am working on my dissertation. My special subject is energy and energy saving. I combine practical work with scientific research. Therefore, in the near future, I am going to defend my PhD thesis. I do research in the field of energy, which is now engaged in very many countries. The subject of my presentation is jet reaction turbine circular efficiency. One of the ways to solve the problem of energy saving and rotation use of the energy potential of our planet is the utilization of the secondary energy resources. Today, a large amount of energy of compressed gas and vapors is lost on reduced and pressure regulators in the gas, chemical and other industries. To solve this problem, it is promising to create turbo-expanded units of low power based on the jet reaction turbine for the utilization of energy of compressed gas and vapors at throttle injection with a payback period of no more than 2 years. Another urgent task of the modern gas transportation industry is to increase the safety of operation of the main gas pipelines by creating a pneumatic gas, the efficient, reliable and easy to use drive of ball valves of large cross-section instead of the currently used pneumatic hydro actuators. This task is also solved by the creation of pneumatic actuators based on a jet reaction turbine. These units allow to produce environmentally friendly energy, mechanical energy on the turbine shaft or electricity from an electric generator, in contrast to classic gas turbine and steam turbine plants, which need to burn fuel to produce this energy. The combustion products of which pollute the environment. That is, we have energy-saving, environment-friendly technology that meets the goal of sustainable development. The research aim is assessing the influence of different factors on the circular efficiency turbine. The research tasks of the work are presented below on the slide. This slide shows two chambers of turbine. The principle of GRT is to convert the potential energy of the compressed gas into the kinetic energy of the supersonic jet flowing from the vehicle. It is known that the traction force Pm has a maximum volume at S equal 1. Accordingly, the moving moment of Mu at S equal 1 will be created then at other values of S. Therefore, the choice of mode S equal 1 is essential. It can be selected, for example, as at startup mode or maximum mode of the GRT efficiency rate. The moving moment presented on this slide also provides a formula for the relation between relative gas flow from velocity of the traction nozzle section and the gas flow velocity of the traction nozzle section in the starting mode. This slide presents the basic formulas for calculations of the turbine circular efficiency. For design and for off-design mode, degree is S equal 1 or S more 1, which including and no including the difference between velocities. I presented formula that shows the relation between relatives, gas flow velocity of the traction nozzle section and gas flow velocity of the traction nozzle section in the starting mode. According to the obtained formula, the graphic dependence of top GRT circular efficiency on the given circular velocity of the impeller at different values of the inlet pressure in the GRT in the range from 2 to 10 MPa. Analysis of the figure 3 diagram concludes that the same circular velocity increases efficiency within GRT inlet pressure change. The highest efficiency value by the inlet pressure 2 MPa and 10 MPa is 47% and 49% respectively. Comparison of figure 3 and 4 clarifies the exact influence of the traction nozzle of design degree on the GRT efficiency. Higher feed nozzle inlet pressure decreases the of design efficiency, figure 4. For figure 3, the design pressure change influence is minimal while the efficiency optimum shifts to the circular velocity rise. The most significant design efficiency value is about 50%. According to figure 4, the efficiency optimum with an inlet pressure of 2 to 10 MPa shifts within the circular velocity of 0.4 to 0.43. The maximal efficiency is 42% at 2 MPa. At figure 5 presented our dependence of design circular efficiency change on circular velocity. Efficient stops are indicated in figure 4 and 6 with a circular velocity of 0.47 to 0.5. Analyzing this diagram provides an opportunity to assess of design degree on the GRT efficiency. In figure 7 there is a dependence of circular efficiency change on circular velocity during the end of design GRT modes. According to the diagram, when S equal 1 efficiency is the highest, the most significant value for 10 MPa is traced with S equal 42. The obtained figure 7 efficiency dependencies. Dash lines implies shaft efficiency. Figure 8 Figure 9 indicates the dependencies of top design, the right extreme point, and of design circular efficiency change on the dimensionless gas flow velocity in the traction nozzle section. This graph gives us a lot of useful information. In conclusion, I must say that such dependencies is obtained for the first time. The main conclusions of the work are presented to you on this slide. We derived GRT circular efficiency different formulas. According to the obtained formula, the graphical dependencies of top GRT circular efficiency on the given circular velocity of the impeller at different values of the inlet pressure in the GRT in the range from 2 to 10 MPa and their analysis. This research was supported by the Research and Educational Center for Industry Engineering by Sumy State University and International Association for Technological Development and Innovation. And I would like to thank our colleagues from Manufacturing Technologies of Technical University of Košice for the successful internship in which we resolved the results for writing our article researches. Thank you for attention. My report is over.
Good day, dear colleagues. My name is Mykola Radchenko. I am a doctor of technical science, professor, a head of air conditioning and refrigeration department of Admiral Makarov National University of Shipbuilding, Ukraine. Let me introduce some results of our investigation in turbine intake air combined cooling systems. The efficiency of application of absorption lithium bromide chillers for turbine intake cooling in temperate climate is considerably reduced, that is caused by decreased ambient air temperature drops. The latter is limited by a comparatively raised temperature of chilled water from absorption chiller of about 7 degrees centigrade that makes it impossible to cool air lower than 15 degrees centigrade. The application of low boiling refrigerant as a coolant enables deep turbine inlet air cooling to 10 degrees centigrade. Thereby, the low boiling refrigerants can be used as subsequent cooling air after its pre-cooling in absorption chiller. A refrigerant ejector chiller is the most simple in design and cheap and can be applied for subcooling air from 15 to 10 degrees centigrade. The aim of research is to develop the advanced turbine intake cooling system with combined absorption ejector chiller to provide deep air cooling and improved method to determine rational design of refrigeration capacity. Research task: development of advanced combined turbine intake cooling system with absorption chiller as a high temperature stage for cooling ambient air to 15 degrees centigrade and ejector chiller as a low temperature stage for further subcooling air from 15 to 10 degrees centigrade. Development of method to determine a rational refrigeration capacity of absorption ejector chiller and distribute it between absorption and ejector chiller to reduce a design refrigeration capacity and to cover peak loads simultaneously. Here you see the main correlations and approaches in research methodology. The annual gas turbine fuel reduction is accepted as primary criterion to determine a rational design refrigeration capacity. The current values of fuel reduction have been yearly summarized according to this equation. Temperature drop due to turbine intake cooling, time operation of turbine at decreased temperature, turbine power output, and specific fuel decrease for 1 degree centigrade air temperature dropped. A refrigeration capacity for air mass flow rate is calculated according to this equation. Air mass flow rate, temperature drop due to cooling, and specific heat ratio and specific heat of wet cooler. General approach: variations of the current turbine fuel reduction due to turbine intake cooling are considered by the rate of annual fuel reduction increment as its relative values referred to required refrigeration capacity. A developed scheme of absorption ejector turbine intake cooling system is presented here. Ambient air is pre-cooled by absorption chiller to 15 degrees centigrade and then subcooled by ejector chiller down to 10 degrees centigrade. Both absorption chiller and ejector chiller use the exhaust heat of gas turbine. Here you see the results of calculation design refrigeration capacity of turbine intake cooling system. This is the curve of annual fuel reduction saving due to cooling to 10 degrees centigrade and in absorption ejector chiller and to 15 degrees centigrade in absorption chiller. The optimal value the optimal value of design refrigeration capacity provides maximum rate of annual fuel saving increment. The rational value of design refrigeration capacity provides approximately maximum annual fuel saving. In both cases, the relative value of annual fuel saving increment referred to required cooling capacity is used as indicator to calculate the maximum rate of annual fuel saving increment. In order to calculate the optimal value of design refrigeration capacity, it's providing the maximum rate of annual fuel saving, it's necessary to determine the maximum value of this ratio within the overall range of the variation. As you see, point O on the curve of annual fuel saving increment indicate the optimum value of design refrigeration capacity, providing the maximum rate of annual fuel saving increment. In order to calculate the rational value of design refrigeration capacity, it's necessary to determine the maximum ratio of annual fuel saving beyond the optimal value within this range of annual fuel saving and required design refrigeration capacity. So you see, the rational design of a turbine intake cooling system provides decrease of installed refrigeration capacity by about 15 and 20 percentage decrease as compared to traditional designing method. The next step in designing methodology is aimed to distribute the rational design refrigeration capacity between ejector chiller and absorption chiller. With this, the refrigeration capacity of absorption chiller is determined as a remaining value between rational design refrigeration capacity of the overall absorption ejector chiller and ejector chiller. As you see, the booster value of absorption refrigeration capacity is much higher than it's necessary to cover current thermal loads for cooling ambient air to 15 degrees centigrade. So it's quite reasonable to reduce design refrigeration capacity of absorption chiller nearly twice and take the design refrigeration capacity needed for cooling air to 20 degrees centigrade as design refrigeration capacity to cover current thermal loads for cooling ambient air to 15 degrees centigrade. You see, this boost value needed for pre-cooling to 20 degrees centigrade is much higher than it's needed for cooling ambient air to 15 degrees centigrade. Here you see the results of calculation of rational value of design refrigeration capacity for absorption chiller reduced rational value for cooling degrees ambient air to 20 degrees centigrade to 20 instead of initial value for cooling to 15 degrees centigrade. As you see, the rational value for cooling to 20 degrees centigrade is nearly twice lower than rational for cooling degree to 15 degrees centigrade. Rational design provides decrease of installed refrigeration capacity of absorption chiller by about 15-20 degree percentage compared to its maximum value according to conventional designing, as you see this value. A design refrigeration capacity of absorption chiller can be reduced practically twice instead of this value. We accepted this value. Due to using the rational value of refrigeration capacity needed for cooling air to 20 degrees centigrade as the design value. With this, the excess of design refrigeration capacity at reduced current thermal loads has to be used to cover peak loads. Conclusions. A new trade in enhancing turbine intake air cooling efficiency by application of combined absorption ejector chiller is proposed to temperate climatic conditions that provides practically twice higher annual fuel reduction as compared with absorption chiller. An advanced method of turbine intake air cooling system rational design is developed to achieve practically maximum annual fuel reduction value at the installed refrigeration capacity reduced by 15 to 20% compared with conventional design practice. The method is based on the rational distribution of the overall design refrigeration capacity of absorption ejector chiller between absorption for ambient air pre-cooling with its unstable thermal load range and ejector chiller for further air cooling within the comparatively stable load range. With this, the annual fuel reduction of gas turbine is assumed as primary criterion, and the variation of the current fuel reduction due to turbine intake air cooling are considered by the rate of the annual fuel reduction increment as its relative values related to required refrigeration capacity. The maximum rate of annual fuel reduction and minimum sizes of chillers is achieved at the optimum design refrigeration capacities. Thank you very much for your attention.
Good afternoon. My name is Marina Savchenko-Pereva. I represent the Sumy National Agrarian University. Topic of my report: Innovative Hybrid Power Plant Design. 1. Introduction. Only sustainable development of humanity can ensure the further progress of life on Earth with the satisfaction of the needs of society, while not threatening the ability to meet the needs of future generations. Currently, humanity is limited in energy consumption, because available generation capacity is insufficient. New energy technologies are not used globally and their development leaves much to be desired. It should be noted that the existing methods of energy transfer inhibit its uniform distribution. In addition to the high cost of equipment, the processes of long-range energy transmission lead to significant energy losses according to some data, up to 20% of the amount of power generated. Traditional energy which uses fossil fuel and energy resources is a threat to a stable climate and planet ecology. The main hazard is an increase in the atmosphere temperature, as well as its pollution. Developed countries of the world are elaborating new doctrines on fuel and energy complexes, which provide for the global introduction of alternative energy sources, such as wind and solar ones. One of the ways to do so is to develop a wind-solar power plant, called hybrid, which simultaneously uses both wind and solar energy. Hybrid wind-solar power plants may be preferable compared to independent solar and wind power plants, especially as the autonomous power supply for cottages, small farms, mini enterprises of food industries, etc. The uninterruptible power supply from a centralized source is not fully guaranteed for various reasons. To ensure uninterruptible power supply, along with centralized power system, it is advisable to use local low-powered autonomous power plants located close to energy consumers. 2 Aim and research tasks. The aim of this study is to study the prospects of using vertical axial wind turbines of medium speed with a new type of blades in a wind-solar power plant based on the results of studies of wind turbines, models of proposed wind power plants, and analysis of the features of the joint operation of the proposed wind power plant and solar cells with further use of energy. Research tasks. 1. Analyze sources of information on the possibility of implementing wind-solar power plants, especially autonomous ones. 2. To explore the prospects for the use of medium-speed vertical axial wind turbines with a new type of blades as part of a wind-solar power plant. 3. Justify the prospects of a new type of medium-speed 1.3 vertical axis wind turbines for use in wind and solar power plants 1.3. 4. Analyze the features of the joint operation of the proposed wind farm and solar panels with further use of energy. 5. Offer recommendations on the choice of an electric generator and converter devices, taking into account the features of the wind farm being designed. 3. Research methodology. There are many designs of vertical axial wind turbines in the world. A new type of vertical axial wind turbines with original blades having an open aerofoil has been developed. Capacity characteristic of wind turbines with such blades have shown that their power speed coefficient theta is in the range from 1 to 3, the so-called average speed. Studies shows the presence of self-starting wind turbines, a fairly high utilization coefficient of wind energy and operation at both high and low wind speeds. The research was carried out at the aerodynamic stand of Summa State University and the wind tunnel of National Aerospace University Kharkiv Aviation Institute. In the experiments the following parameters were measured: wind velocity, the torque on the propeller axis, the number of revolutions of the axis of the model propeller. Using obtained parameters, the wind energy utilization coefficient P and the power speed coefficient theta were determined using these formulas. The average speed coefficient is according to the formula. 4 results. 4.1 Key research results of the wind wheel model with original blades of medium speed. As a result of the experiments carried out in a wind tunnel, the capacitive characteristic of a wind wheel with KNM blades in the coordinates theta is shown in Figure 1. It should be noted that full-size wind wheels may have a higher wind energy utilization coefficient CP, comparing to the model due to the scale effect. Based on the results of physical experiments, we distinguished generalized analytical expressions for the capacity characteristic obtained during our study of specific vertical axial wind wheels of medium speed with KNM or KN6 blades. Analysis of the capacity characteristic of vertical axial wind power installations shows that in general, the dependence curve Cp equals F, theta, may be approximated by cubic, left branch, and quadratic, right branch of the characteristic, parabolas that have a common vertex at the point with the ordinate C, P max. As a result of this approximation, the equations for calculating the left and right branches of the wind power installation were obtained. The test showed that these equations are also valid for vertical axial wind power installations with original KNM blades. Obtained values correspond to experimental findings. Tests of the wind turbine with the original KNM blades showed the presence of self-starting. Figure 2 shows capacity characteristic of vertical axial wind wheels with original KNM blades relative to the criteria of ETS, Gluer, and known vertical axial wind turbines. As already noted, the value of the power speed coefficient theta of a specific wind power station is within 1.85, so the circumferential speed of the blade and the number of revolutions of a wind power station shaft is low. Thus, the operation of a medium-speed wind turbine is accompanied by a significant decrease in the centrifugal force on the blades compared to high-speed ones, since the reduction value depends on the ratio of circumferential speeds of the blade for the same blade mass and radius of rotation. This is certainly a positive effect since the requirements for structural strength are reduced. In addition, the low value of the circumferential speed of blades causes low noise characteristics. Therefore, the new type of vertical axial wind turbines with a sufficiently high wind energy utilization coefficient possesses improved characteristics of strength, reliability, ecology, and maintenance. Thus, taking into account the above, the use of a wind turbine of a wind unit with KNM blades in a wind solar power plant is very advisable. 4.2. Analysis of simultaneous working wind power stations and solar cells with energy utilization. As for the solar energy, factors such as location latitude of solar radiation receivers, the time of the year and the daily irradiation play a determining role. Daily irradiation is generally determined by the formula. The intensity of solar radiation G includes the components of directed and scattered radiation. Thus, the feasibility of solar cells should be analyzed in each specific case, depending on the location latitude, the range of changes in incidence angle of the directed radiation flow, the presence or absence of atmospheric pollution, and other climatic conditions. Electric energy from solar cells can be obtained in two ways: utilization of a heat engine and photovoltaic generation. At a hybrid power plant, of course, as a source of electromotive force should be used solar cells that are functioning in the presence of a radiation flux. Thus, the amount of energy that can be obtained from a solar cell can be determined by the formula, where G is the intensity of solar radiation at a given period, T is the period under consideration, CPC is the efficiency coefficient of a solar cell. The amount of solar insolation in a specific area can be found in the relevant sources. The efficiency coefficient of a solar cell is the ratio of the battery energy to the energy Y of the solar flow at a specific area on the receiving surface of a solar cell. Capacity characteristic of a wind solar power plant is the sum of two energy sources' capacities, which ensures greater stability of its supply to the consumer. In general, the amount of energy received over a certain period can be determined by the formula. The annual amount of energy can be determined using the formula. Conclusions. The wind energy utilization factor of the proposed vertical axis wind turbine of medium speed has a high value for the range of average speed coefficient, 1 less than or equal to theta less than or equal to 3, and is at the world level of values of the wind energy utilization factor of both low and high speed wind turbines. The circumferential speed of the blades in the proposed wind turbine is low. This causes a small amount of centrifugal force, which is important from the point of view of the requirements of strength and reliability of operation. The presence of self-starting of the wind wheel and the absence of wind orientation requirements greatly simplifies the maintenance of the power plant. The low circumferential speed of the wind turbine blades ensures a low noise level, which allows the power plant to be located near housing. Changes in solar insolation to some extent follow a certain pattern and can be predicted, while changes in the speed and, consequently, wind energy are unpredictably. In the second case, not only the amount of energy received changes, but also the circumferential speed of the blades, and the number of revolutions of the axis, shaft, of the wind turbine. Formulas are proposed for determining the amount of energy that will be generated by a wind solar power plant for a certain period of time. Since the amount of energy produced in wind solar power plants is unstable, it is necessary to use accumulation and storage systems in order to organize an uninterrupted supply of high-quality energy to the consumer. They allow storing excess electricity produced and use it in calm and cloudy weather. The speed of the wind turbine of the proposed wind power stations, 1-3, is low, especially for a high-power one. This causes the use of multipliers to increase the number of revolutions, which reduces the overall efficiency and increases the cost of the wind power station. Thus, it is logical to use low-speed generators with soft characteristics for a wind power station. The choice of accumulating and converting devices is generally determined by the required amount of energy delivered over a certain period, requirements for its quality and consumer's schedule, on the one hand, and on the other hand time required for energy accumulation. For an autonomous power plant, uninterrupted energy supply to the consumer, obviously, is possible due to the storage device that accumulates the required amount of energy, which can be distributed over time according to consumer's schedule. Thank you very much for your attention.
Good day, dear colleagues. Let me introduce some results of our investigation in exhaust heat recovery in integrated energy plant. This research was conducted in Admiral Makarov National University of Shipbuilding, Ukraine. The combined refrigeration, heat and power generation trigeneration achieved wide application in integrated energy plants with gas engine as drive engines. The heat released from gas engine is used for heating water to about 90 degrees centigrade. The heat of hot water is used by absorption lithium bromide chiller to produce chilled water used for technological needs. The absorption chiller operates efficiently with COP of about 0.7 if the temperature drop of hot water is about 15 degrees centigrade. With this, the temperature of return warm water is about 75 degrees centigrade. So as the return warm water is used as cooling fluid to remove the heat from gas engine, its temperature at the inlet of gas engine has to be less than 70 degrees centigrade. To satisfy such contradictory requirements, the excessive remaining heat of return warm water is removed to atmosphere by radiator. Meanwhile, with raising gas engine intake temperature, the electrical power decreases and fuel efficiency falls. Thereby, the excessive heat remaining from absorption chiller is reasonable to use for cooling engine intake air. The aim of research is to convert the heat of returned hot water not used by absorption chiller and removed to the atmosphere in typical integrated energy plant to refrigeration by ejector chiller for engine intake cooling to provide the effective operation of the engine. Research task: analyzing the monitoring data on the perimeters of gas engine heat utilization circuit to estimate the results for utilizing the excessive heat not recovered by absorption chiller. Development of the circuit for deep utilization of the heat released from gas engine in absorption ejector chiller. The integrated energy plant of the factory Sandora PepsiCo Ukraine consists of two gas engine and absorption chiller. Here you see the high pressure, the high temperature scavenge air cooler, low temperature scavenge air cooler, exhaust gas boiler or economizer, engine jacket cooler, lubricating oil cooler, absorption chiller, which is used exhaust gas heat, high temperature scavenge air, and heat removed from engine jacket cooler and lubricated oil cooler to transform into refrigeration, which is used for technological needs, and in the central air conditioner to cool outside incoming air to engine room. The gas engine sucks air from engine room. Here you see the typical scheme of heat utilization. Absorption chiller is used hot water of the temperature of 90 degrees centigrade to generate refrigeration in the form of chilled water. This chilled water is used in the central conditioner for cooling engine room intake air. The temperature of hot water after absorption chiller is about 75 degrees centigrade. In order to keep safe operation of gas engine, the temperature of incoming hot water should be less than 70 degrees centigrade. So the heat equivalent of this difference of about 5 degrees centigrade is rejected to atmosphere by emergency radiator. Here you see the results of monitoring data of hot water temperature at the inlet of absorption chiller and at the outlet of absorption chiller of about 75 degrees centigrade, and the temperature of warm water at the inlet of gas engine after extracted excessive heat to atmosphere. The corresponding heat consumed by absorption chiller is about 1000 kilowatt, and heat not consumed by absorption chiller and lost through extracting to atmosphere by emergency radiator is about 400 kilowatt. And here you see the refrigeration capacity produced by absorption chiller and not produced by absorption chiller because of heat losses extracted to atmosphere. We developed the scheme of heat utilization released from gas engine in absorption chiller and ejector chiller, which is used remaining excessive heat to produce refrigeration for cooling engine intake air in air cooler. To reduce engine intake air and increase engine fuel saving and power output. Conclusions. The analysis of converting the heat released from gas engine to refrigeration by absorption chiller in typical integrated energy plant proceeding from monitoring data on the temperatures of hot water during utilization of its heat revealed the heat losses of about 40% of the heat converted in absorption chiller. The innovative waste heat recovery technology for integrated energy plant through converting the remaining heat not used by absorption chiller and usually removed to the atmosphere in ejector chiller to generate additional refrigeration for gas engine intake cooler is considered as the simplest solution to be implemented at the typical integrated energy plant. The absorption injector chiller with the low temperature ejector chiller and the high temperature absorption stage for deep waste heat recovery system is proposed. Such deep-based heat recovery system makes it possible to enhance engine fuel efficiency due to intake cooling and to prolong the time of integrated energy plant efficient performance even within periodical technological cooling needs. Thank you for your attention.
Hello everyone, I'm Victoria Korniyenko, PhD of Admiral Makarov National University of Shipbuilding. The topic of my research is protection of condensing heat exchange surfaces of boilers from sulfuric acid corrosion. The exhaust gas temperature largely determines the economic performance of exhaust gas boilers. It's more difficult to reduce of exhaust gas temperature since its value about 160 degrees is determined by the rate of low temperature corrosion, which sharply increases at 130 degrees and reaches the level of the corrosion peak, 1.2 millimeter per year at 110 degrees, reduces the workability of heat exchange surface. Consequently, the thermochemical processes in the gas duct of boilers and the low temperature corrosion intensity significantly limit the possibilities of increasing the efficiency of boilers and the depth of exhaust gas heat utilization of internal combustion engine. Therefore, any measures to reduce the level of the corrosion peak to an acceptable level about 0.2 millimeter per year will provide reliable work of condensing heat exchange surfaces, increase the boiler efficiency and fuel saving. The aim of research is to confirm the passivation of metal on boiler condensing heat exchange surfaces when water fuel motion combustion. Experimental studies of low temperature corrosion intensity were carried out when fuel oils and water fuel motion with different content were burned. The research was carried out experimental setup where it's possible to ensure the stability of all parameters. This increased the reliability of the obtained results. A general view of the experimental setup and tube sample are presented on figure 1. In addition to determining the corrosion rate, analysis of deposits composition were performed to determine the content of nitric oxides and iron ferrum 3. The content is largely defining the passivation possibility of metal surface. The nitric mechanism for producing sulfuric acid is based on the absorption of SO2 and NOx. Therefore, it's possible to confirm the presence of this process in pollution on condensing heat exchange surfaces when water fuel motion combustion. For this, it's necessary to determine the change in the content of the SOx and NOx in exhaust gas before and after these heat exchange surfaces, with an increase of water content in water fuel motion. Taking into account the data of direct measurements of nitrogen oxides content and the relative content of ferrum 3 in pollutions, experimental data on the intensity of low temperature corrosion when water fuel motion combustion, it can be argued that in this case there is an additional passage of the nitric mechanism of sulfuric acid formation in pollutions at the condensing heat exchange surfaces at temperatures below the dew point temperature of sulfuric acid vapor. In addition, direct measurements of the content of SO2 and NO2 in exhaust gases when water fuel motion combustion and the obtained ratio NO2-NO will give reasons to assert the possibility of nitric process in condensate of the heat exchange surfaces. The results. An analysis of exhaust gas composition showed figure 2, when the water content of emulsion is increased, the NO2-NO ratio approaches to equimolar mixture. In order to confirm the passivation of metal on boiler condensing surfaces, the dependence of content of absorbed NOx in acid condensation on condensing heat exchange surfaces from the metal surface temperature was obtained, figure 3. The level of content of NOx in condensate on condensing heat exchange surfaces corresponds to sulfuric acid production with a nitric mechanism. In technological term, this production, in order to reduce the corrosion of sulfuric acid coolers, the phenomenon of passivation of carbon steel metal surface is provided at the expense of absorbed nitrogen oxides. In the course of research, the dependencies of corrosion rate figure 4a and ferrum 3 content figure 4b from temperature of metal heat exchange surfaces are obtained. There is a minimum amount of ferrum 3 at temperature 110 degree and 60 degree. On contrary, the maximum value of ferrum 3 content are found at 80 degree and 130 degree, where there is a minimum corrosion rate. There is a scene of growth of passivation phenomenon of metal surface. The comparison of the dependence of corrosion rate on the water content in water-free emulsion figure 5b and the dependence ferrum 3 content in the corrosion products on water content figure 5a indicates that with increasing of water content in the emulsion, the corrosion rate decreases and reaches a minimum value at 30%. The content of ferrum 3, which is a scene of passivation of metal surface, increases accordingly and reaches a maximum value at the same value, 30%. This means that the most passive state of the metal surface is achieved when water content is 30%. The research results figure 6 show when water-free emulsion is burnt, the low temperature corrosion intensity is at the level 0.25 millimeter per year in the range of the low temperature 70–130% degree in the absence of corrosion peak. Therefore, the main factor contributing to a significant reducing of low temperature corrosion when water-free emulsion is burnt with a water content of emulsion more than 20% is occurrence of metal passivation. Conclusions. This method of protection of metal from low temperature corrosion provides resistance to thermal and dynamic deformations on the metal surface due to a very thin passive film with a thickness of about 50 angstrom. This film has a reliable connection with the metal at the crystal structure and eliminates direct metal contact with the aggressive environment. Improving the boiler efficiency in the protection of metal on condensing heat exchange surfaces in this direction is achieved by increasing the stability and operation duration of the metal due to the constant automatic creation of a passive layer due to the occurrence of physical-chemical processes in contact with the exhaust gas flow at metal surface temperature below dew point temperature of sulfuric acid vapor, 130 degree and 270 degree. It makes possible to reduce the temperature of the exhaust gases to 80 degree and thus significantly increase the efficiency of boilers. Thank you very much for your attention.
Good day, my name is Maxim Peresunka. I work at the Admiral Makarov National University of Shipbuilding. The topic of my presentation is marine diesel engine inlet air cooling by ejected chiller on the Vessel Road line. It was written in collaboration with Andrei Radchenko, Veniamin Tkachenko, Anatoly Zubarev and Artem Andreev. I would to start with introduction and major challenges. A fuel efficiency of combustion engine, gas turbine and gas engines. Internal combustion engines, including diesel engines, considerably depends on the temperature of sucked air falling with its raising. Low-speed diesel engine gains the most wide application as the main ship engines. Their specific fuel consumption increases by 0.11 to 0.12 gram kilowatt per hour for 1 degree Celsius. Increase in the temperature of air at the section of engine turbocharger. In order to enhance the fuel efficiency of the engines, the sucked air at the intake of turbocharger could be used. The heat losses with exhaust gas and scavenged air consist a main part of the total waste heat in combustion engines. Therefore, the waste heat recovery chillers can be applied for engine air cooling. The absorption lithium bromide chillers are the most used for cooling air to about 10 degrees Celsius, with a high coefficient of performance of 0.7 to 0.8, but large size make mounting the absorption chiller unit in engine room problematical. The ejector chiller consists of heat exchangers suitable for mounting in free space. They enable deep cooling air, but with a low coefficient of performance of 0.2 to 0.3 and suitable to transport applications. Let's move on to the next slide. The research aim is to estimate the efficiency of cooling the sucked air of marine low-speed diesel engine by waste heat recovery in ejector chiller with account the changeable climatic condition during the voyage line. Research tasks. There are analysis fuel efficiency of marine slow-speed diesel engine with cooling the air at the turbocharger section by ejector chiller that recovers the waste heat of exhaust gas and scavenged air. Evaluate the current air temperature drops in the air cooler at the turbocharger section and corresponding reduction in fuel consumption of the marine diesel engine and a changeable climatic condition along the road line. And consider the proposed scheme of the system for cooling the air at the turbocharger section by ejector chiller. The next slide shows research methodology. A low-speed MAN diesel engine 6C60MC 6.1 Tier 1 is chosen as an example of the main drive engine of transport ship. Rated power of main engine is 12.24 MW and continuous operating power 10 MW. The engine turbocharger sucked air cooling efficiency is estimated by specific fuel consumption reduction gained due to the sucked air temperature drop. The following characteristics of the ejector chiller for cooling the ship engine intake air were chosen. Refrigerant Freon R142B. Refrigerant evaporation temperature in the evaporator air cooler is 5 degrees Celsius and in the generator is 80 to 120 degrees Celsius. Refrigerant condensing temperature in the condenser is 25 to 45 degrees Celsius. According to the calculation with using MAN diesel turbo saltwater package, cooling turbocharger inlet air for every 1 degree Celsius of temperature drop results in reduction of specific fuel consumption with 0.11 to 0.12 gram kilowatt per hour for chosen main diesel engine. The calculation of the characteristic of the engine was carried out on the operation mode during the voyage routes Odessa-Yokohama and Yokohama-Odessa. You can see in the slide the characteristic of climatic condition along the voyage routes. The values of ambient air temperature and relative humidity were taken each 3 hours along the voyage routes by applying the program Meteomans.com. Next slide shows calculation formulas. There are the available refrigerating capacity, the temperature of cooled air at the air cooler outlet, the current values of specific fuel consumption reduction per 1 hour, the total fuel reduction per 1 hour. The next slide shows you circuit of diesel engine section air cooling system by ejector chiller recovering the heat of exhaust gas. The heat of engine exhaust gas is consumed by generator of ejector chiller to generate the refrigerant vapor of a high pressure as a motive fluid for ejector to compress the refrigerating vapor of a low pressure sucked from evaporator air cooler at the engine turbocharger section up to the condensing pressure of refrigerating in the condenser. You can see in the slide changes in the air temperature drops as the temperatures of cold air available due to recovering exhaust gas heat by ejected chiller for each time interval of 3 hours on the voyage route Odessa-Yokohama and Yokohama-Odessa. Temperature reduction of turbocharger sucked in air in the air cooler is about 10 degrees Celsius. It is just enough to compensate the temperature increment of about 10 degrees Celsius for ambient air incoming the engine room caused by heat influx from engine room environmental. Next figure shows you a specific fuel consumption reduction due to the engine sucked air cooling by ejected chiller using exhaust gas heat is 1.0 to 1.2 gram kilowatt per hour. Absolute fuel saving during the voyage route is about 15 ton and relative fuel saving is about 0.7%. The next slide shows you a circuit of developed engine turbocharger sucked air cooling system with ejected chiller recovering the exhaust gas and scavenged air heat. With this, scavenged air heat is used in economizer section of refrigerant generator to increase the temperature of liquid refrigerant from condenser to the temperature of its boiling in environmental section of generator by using the heat of exhaust gas. The next slide shows the results of calculation of fuel efficiency and enhancement of main diesel engine due to its turbocharger, sucked air cooling by ejected chiller recovering the heat of exhaust gas and scavenged air on the routes line Odessa-Yokohama and Yokohama-Odessa. As it is represented in the slide, a reduction of specific fuel consumption due to turbocharger sucked air cooling by recovering the heat of exhaust gas and scavenged air in ejected chiller on the rows line is 2.0 to 2.5 gram kilowatt per hour. With this summarized, absolute fuel saving is 26 to 28 tons, and its relative value is about 1.3% from marine diesel engine 6S60 MC 6.1 Tier 1. Main topic of my presentation you can see on the slide. It's shown that the application of ejected chiller provides reduction in the engine intake air temperature by about 10 degrees Celsius with corresponding decrease of specific fuel consumption by 1.0 to 1.2 gram kilowatt per hour when using only the heat of exhaust gas. The fuel reduction of marine diesel engine is increased practically twice when additional heat of scavenged air is used by ejected chiller. The corresponding schemes of the systems for cooling the air at the turbocharger section by ejected chiller are proposed. The application of ejected chiller provides reduction the engine intake air temperature by 20 to 23 degrees Celsius with corresponding decrease of specific fuel consumption by 2.0 to 2.5 gram kilowatt per hour. In order to provide a deeper engine intake air cooling to the temperature of about 10 degrees Celsius and lower, it is necessary to apply two-stage cooling air in a hybrid water refrigerant air cooler by combined absorption ejector chillers with a higher coefficient of performance. Thank you very much for your attention.
So we have ended the presentation, and we have seen all the different presentations devoted to the of each of the presentations, and after that we can be able to answer the questions, and I hope that the presenter will be able to answer. So the first presentation was presented by Dmitry Kamalov. I hope Mikhail can hear us. Mikhail, are you here?
Yeah, I hear.
Okay. So thank you very much. using the gas turbine, using the thermodynamic compression. So maybe somebody has the question. I haven't seen in chat, but maybe I can ask you, because according to your research, the efficiency of the turbine and compressor was assumed to be 0.86, and I don't understand this value. Is a joint efficiency of the unit, or it's just value of the efficiency turbine, or only the compressor? Mr. Can you see me? Hello, hello. It seems to me we have some technical problems, because or I can hear the Dmitro, or Dmitro can see me. If this problem from my side, please write in the chat that you hear and you are online. Okay, maybe we'll back to Dmitro Konovalov in a couple of minutes. And the second presentation was presented by Andrei Rogovin. Andrei, are you here? Seems to me that it's some of them, they don't hear. So please wait, we will try to fix. I don't know what to do this, because we don't see here. Before they answer the
Сейчас нет Андрея Рогова. Андрея Рогова. Я сейчас жду, пока она появится. Я понял.
Okay, maybe Tatiana, are you here?
Yes.
Oh, I see. It seems to me that Tatiana is at conference room at Sumy University, but you have muted microphone, so please turn on your microphone.
My microphone. You listen me?
Do you hear us? Do you hear us?
Yes, now we hear you.
But now?
And you muted the microphone again.
Okay.
So now it works. Okay, so we are Tatiana Vinchenko, and she presented the Summer State University, Ukraine. It's a pleasure to see you. And your presentation was devoted to the jet reactive turbine circular efficiency. And I unfortunately can't see the questions from the colleagues here in chat as well as on YouTube, but I have the parameters of the tubing, because you have to know these parameters to conduct your research and be presented.
We calculated our research in flow vision.
And what type of the mesh was used? Was it unstructural or structural mesh?
Не помню. Там же одна сетка.
Тип сетки при моделировании какой использовался? Загальная сетка с локальной адаптацией. General Mesh.
General Mesh.
With local adaptation.
With local adaptation.
Okay. Now, local adaptation in the places there the geometry was changed, yes? But I'm interested what kind of the mesh was used. It means was it structural polyhedron or was it unstructural tetrahedron mesh?
Квадратный, да.
Прямоугольная сетка. Rectangular.
Rectangular.
I think it just your colleagues make such calculations and such simulations, yes? If I maybe don't know the such details. So maybe somebody else have questions? Maybe from the Summit State University? Okay,
thank you very much.
Yes?
Thank you very much for questions.
Thank you for your presentation. I hope to see you next year and stationary, and then we can discuss in details what you have done and maybe some propositions how to make the future research can be presented too. Thank you very much.
Thank you very much.
And as I see, there is a Dmitro Konovalov online. Dmitro, I see you have had the internet connection, but maybe now you can hear and you can answer the question. It seems no. Dmitro has the internet.
I'm sorry. Maybe I could answer question addressed to Dmitro Konovalov.
Okay. So maybe let me take a look. There is no question in our chat. Just the same. We've done some questions from YouTube. Maybe you will be able the same. Tell me in which program you calculated the parameters of the tubing.
I see they use ANSYS, but I'm not in details of this program. I supervising, the general results of this investigation and directed some approaches and trends in this field.
I understand. Maybe you can answer, you can tell me, in presentation there was a figure on which we have not distribution, but the changes in pressure in relation to the temperature.
Yes.
And there were two figures on one slide. Maybe our technical support can just pressure, and there is a relation of the pressure in percentages. So it seems to me, how can you
Okay,
compare
yes, can you show me this picture?
the next one?
This one, yes?
This one, yes.
And what, yes, it's pressure and, temperature decrease. You know, the performance of thermopressor is based on quick, I think, increase of pressure due to momentum, I should say, momentum evaporation of water evaporated in this, without practically without any pressure drop for resistance. You know, and in this case, when we use the temperature decrease. If temperature decrease is temperature depression locked for thermopressor. If the temperature depression is higher, so the higher pressure increase. You know, and this picture presents this correlation. Because if we have, for example, for 300 temperature depression, so in this case we have the maximum value of pressure enhancement. But in reality, in real installation, of course, we work about 100 temperature depression, you know. Temperature depression due to this cooling, due to evaporation of water in this two-phase flow, I should say.
Okay, thank you very much for your answer. And please tell the Dmitro that his presentation was very interesting, and maybe somebody will send the answer by mail, so I hope some cooperation can be in the future.
I think he is looking forward for joint cooperation. Thank you very much.
Thank you too. So the next presentation was made by Ludmila, Marina Savchenko-Tereva. Marina is here. I almost can't see you. Can you just make louder your microphone, or maybe closer
self-starting. And this advantages our hybrid turbine. Coefficient wind approximately 3. It's enough for kind of like our wind turbine.
And can you tell me the traditional construction of such power plant has bigger or smaller efficiency?
Traditional power plant, for example, rotor Savonius have low efficient coefficient, but if comparison with medium speed, we have a great value.
Mm-hmm. Okay, thank you very much, and I wish you only success in your future results, and welcome to the next conference. I hope you will be here and we can meet and discuss your new presentation. Thank you.
Thank you very much.
Okay, and the next presentation was presented by Andrei Radchenko and was entitled Ex-House Heat Recovery in Integrated Energy Plant. And it seems to me I had the Andrei Radchenko, and you're here, yes? Andrei, are you here? We have some problems with connection. It's normal in such situations that we have. So I hope these troubles and these problems do not concern with some problems with war, and it just such as usual low capacity and low internet connection. So maybe Victoria Kornienko is here and can answer the questions. So Victoria didn't hear us. So the last presentation was made by Maxim Peresenko. Maybe Maxim here. We have the same problems because it seems to me that our connection with other rooms are not. I don't know. It seems to me they don't hear us. Maybe they have alarm and go somewhere because there is nobody. It means that they should hear us. Yes, they should hear, but nobody answers. So it seems to me they are absent. Just go out somewhere. So we can finish the session, yes? Maybe. So if somebody is still here, we thank you for your attention, and we hope that you can be able to take a look at the presentation again, find something interesting for you, and some new ideas, some new topics, and as well as the possibility for cooperation with your colleagues from other universities. And we wish you be safe, healthy, and see you next year stationary, I hope, in Sumy State University.
Oh, I'm sorry. My microphone was switched off, and I was answering, for problem with Konovalov and
yes, okay.
in Kherson, and this is occupied. They switched off.
Look, maybe I have some questions for you. So please wait a moment, because it was the turbine intake air combined cooling system.
Yes.
Mm-hmm. So
Just a moment. Some results of your calculation of optimum design refrigeration were obtained for turbine UGT 1000. Yes, maybe you have opportunity to compare the real, I mean the operating maximum rate of the annual fuel saving for such gas turbine.
You know, gas turbine of 10 megawatt was used as example. So it's real gas turbine produced by our gas turbine enterprises in Nikolaev, you know. And it's real gas turbine, and all correlations used here is real and get it from characteristic of this gas turbine. Just as example. But the main purpose of this investigation is to develop the methodology for calculation of this optimal and rational value of design cooling capacity, not just to show actual results, you know, for quite a definite gas turbine, but in reality we will show that for temperate climatic conditions, the most effective approach or trend is to use two-stage air cooling in absorption chiller as typical one down to 15 degrees centigrade, and the next stage is ejector chiller below 15 to 10 degrees centigrade, and we have shown that due to this two-stage intake air cooling, we received nearly 50% in increase of power output and annual fuel saving.
Okay, thank you. Maybe I have only a remark, small remark for your research, because you use such a word practically maximum or optimal values. When we are talking about optimal, we think about the optimization problem solution. And seems to me that in your research you didn't use the solution exactly the optimization problem. So maybe the term optimal is not exactly correct in this.
No. If I show the corresponding, you know, picture slide with A and B in methodology, and I will explain that in reality we use the maximum value of these relative values of annual fuel saving related to installed refrigeration capacity, you know, and you see the maximum of this value correspond to maximum rate of annual fuel saving. So in reality, it's quite, I think, approved, you know, indicator, and we have right to say that it's optimal value just to provide the maximum rate of annual fuel saving increment.
Yes, in this case, the aim function or goal function, according to the methodology of the optimization, is just the minimum of the fuel. Yes.
Yes. Because
okay, now I understand.
Yes. It's they are connected with annual fuel saving, and of course, we can get this.
So I see that we don't have any questions. So thank you very much for your interesting presentation, and I hope you will be here healthy and safe, the same as all our colleagues in Ukraine.
Thank you very much, and for you so.
So. I see that Maxim is now in person and he hasn't the connection. So maybe
I can ask for I can answer the question addressed to him too.
Yes, I see, but I don't. Okay, this was about the marine diesel engine inlet air cooling by injector chiller on the vessel road line. And here we have one question. In your
Professor
research,
Radchenko is a supervisor for all these reports, so
Yes,
he
yes, it's my
managed
school.
to respond.
he answered on all questions in session energy efficiency technologies.
He's a real supervisor, not on the paper.
Real supervisor, yes, of course. So
I have prepared all of them for the PhD and then doctor engineer. So I am in course of the investigation.
So maybe could you just a few words about the software Man Diesel Turbo? What this software is?
Man Diesel.
Man Diesel Turbo, because in your presentation, not yours, but in presentation of Maxim, there was a relation to the software that some of the parameters was calculated.
Yes. I saw. We use this program of diesel engine producer. You know. Yes, and it's real data on fuel consumption, power engine power, and so on.
So the let's say inlet or initial parameters that you need to provide your
yes, but it's another program. It's program for ambient air temperature, current ambient temperature, and seawater temperature. International program, and we believe them results.
Yes, you have a strongly practice proved results, and your investigations can be valuable as well. I understand, and thank you very much.
Thank you very much for your attention.
So it seems to me that they don't have any questions. So thank you again for your participation, for your attention in such a difficult time. And I hope everything will be good and we all be able to do what we want to do for technique, for education, and for our better lives. Thank you.
Grateful to all participants for their contribution. And thank you very much to Dr. Yulia Tarasevich for your commitment, for your time devoted to this session, and thank you very much for this excellent working session. Thank you very much.
Thank you to organization.
Well, thank you very much for exciting meeting, you know.
Dear participants, don't turn it off. We will start the next session right now. So please pay your attention to the next 3 presentations, and I am happy to introduce the next session chair, Dr. Alper Uysal from Yildiz Technical University. He is the representative of the Department of Mechanical Engineering, and he is a chair of session number 10, Mechanical Engineering 2. The stage is yours. Alper, please start your session. Turn it on your microphone, please.
Okay, can you hear me now?
Yes.
Okay, thanks a lot for the introduction. Dear participants and presentations, welcome to our session 10 as Mechanical Engineering 2. The scope of 5th International Conference on Design, Simulation, Manufacturing, the Innovation Exchange, as you know, DSMIE-2022. First of all, I would like to thank you, DSMIE team, and also the organization committee for their efforts to make real this conference. In this session, we have 3 excellent presentation from Ukrainian researchers. If they are ready, we can start the video presentation, and then we can start. We will continue. The first presentation is related to reducing working fluid pulsations in planetary hydraulic machines by rotational design of the distribution systems, and Oksana Yeremenko will present this study. If it's ready, we can start the video presentation.
Three presentations will be started right now.
Okay.
It will
We can
be
start
like
up.
one stream of three presentations, and after that, a question.
We can continue with summarizing them, and then if there are some questions, we can continue with the questions after finishing the video presentations.
Yes.
Okay?
Yes, correct.
Good afternoon. Our research team are grateful for the chance to take part. Good afternoon. Our research team are grateful for the chance to take part in the conference and present our findings. So let me start with introduction and major challenges. The hydraulic drive is widely Our used in research team are construction, grateful for the road, chance to take agricultural, part in the
forestry,
conference and
and other
present our
self-propelled
findings.
machines.
In the hydraulic drives of the working bodies and the running So systems let of me these start with machines, introduction and planetary major or orbital challenges. hydraulic motors are being increasingly used, which make it possible to provide a gearless connection of these hydraulic motors directly to the actuators. A review of G-rotor technologies in hydraulic machines showed that at present there is a few publications on the design, calculation, manufacture, and operation of G-rotor type hydraulic machines. It should be noted that if some information can still be found about G-rotor pumps, then there is practically no research concerning orbital and planetary hydraulic motors. It should also be noted that the issue of reducing the pulsation of the working fluid in planetary hydraulic machines in order to increase the reliability of hydraulic drives of self-propelled equipment as a whole remains unsolved. Therefore, as an urgent task, we consider theoretical studies of the effect of changing the kinematic, geometric, and functional parameters on the reduction of working fluid pulsation and stabilizing the output characteristics of planetary hydraulic machines at the design stages. Now, let's move to the aim and research tasks. The work is devoted to the study of the influence of changing the throughput of distribution systems on the output characteristics of planetary hydraulic machines in order to ensure their stabilization at the design stages. To achieve the goal of the research, some tasks were set. They included the investigation of how such factors as the kinematic diagram of the distribution system, the angular gap between the distribution windows, as well as the number of additional windows, influence on the changes in the pulsation coefficients of the working fluid flow. That made it possible to formulate the starting conditions for the design of distribution systems. Now let us discover some points of the research methodology. Oscillatory processes, which include fluctuations in the flow of the working fluid in the channels of the distribution system arising during the operation of positive displacement hydraulic machines, are one of the negative factors. Therefore, the distribution system of a planetary hydraulic motor can be considered as a possible source of generator fluctuations in the flow of working fluid affecting the stability of the output characteristics of the hydraulic drive as a whole. The developed scheme of the volumetric arrangement of the distribution windows made it possible to visually trace the possible overlapping of the distributor windows during the operation of the planetary hydraulic motor and develop a design scheme to determine the current value of the flow cross-section area. The pulsation of the working fluid flow in the hydraulic motor is caused by the fluctuations in the flow area expressed by the difference between the values of the maximum and minimum flow cross-sectional area described in the paper. It has been established that the main influence on the fluctuations in the flow area is exerted by the kinematic diagram, overall dimensions, and angular clearance between the distribution windows. The analysis of the equation showed that the change or fluctuations in the flow area of the distribution system depend on its kinematic diagram, which is defined by the number of the fixed distributor windows. The pulsation coefficients of the throughput of the distribution system and the rational speed of the hydraulic motor shaft, the pressure of the working fluid and the torque on the hydraulic motor shaft have also been substantiated and described. Analysis of the given expressions show that the main influence on the value of the working flow pulsation generated by the distribution system of the planetary hydraulic motor is exerted by the fluctuations in the area of its flow section. Now, moving to the results. The studies of the influence of the kinematic diagram, angular clearance, and the number of additional windows on changes in the pulsation coefficients of the working fluid flow were carried out by simulating the working processes occurring in the distribution systems of planetary hydraulic machines using the DSMIE application package. Taking into account our findings, the initial conditions have been adopted and justified. Analysis of the pulsation coefficients change when additional discharge windows are not used showed that for such kinematic schemes as 5 to 4, 9 to 8, and 13 to 12, zero pulsation of the working fluid is ensured with a number of zero additional discharge windows and zero angular gap between the distribution windows. When additional discharge windows were used in the kinematic schemes such as 7 to 6 and 11 to 10, zero pulsation of the working fluid could be provided when two additional discharge windows were designed and the angular clearance equaled 0. Sufficiently good results were obtained for the 7 to 6 scheme when we used two discharge windows and the angular gap equaled 0 degrees, 25 minutes, and 30 seconds. The use of such a gap allowed to increase the volumetric efficiency of the hydraulic motor with a relatively low pulsation coefficient of up to 2.5%. When the design requires to use 3 additional windows with an angular gap equal to 0 degrees and 51 minutes, it is possible to ensure the maximum value of the volumetric efficiency of the distribution system for 76 and 13 to 12 kinematic schemes when the pulsation coefficient changes by 2.5%. It was found that when 4 additional windows were used, changes in the pulsation coefficients of the throughput, the rotation frequency of the hydraulic motor shaft, the pressure of the working fluid, and the torque corresponded in nature to the results when the number of additional windows equaled 0. The value of the pulsation coefficients with such indicators of the distribution system has almost halved. The recommendations included kinematic schemes 5 to 4, 9 to 8, and 13 to 12 with a 0 value of the pulsation coefficient and a 0 angular gap between the windows, as well as 5 to 4 and 11 to 12 schemes with an angular gap equal to 0 degrees and 51 minutes, which gave quite acceptable values for the pulsation coefficients of up to 5%. To make conclusions, we should state the following things. The design scheme and mathematical operators were developed and the initial data were substantiated that allowed to study the influence of the changes in the geometric parameters of the distribution system on the pulsation of its flow area depending on the kinematic scheme, the angular gap between the distribution windows, and the number of additional windows. The use of discharge windows on the movable distributor as additional ones allowed not only to ensure the kinematic correspondence of the distribution system with the number of teeth of the planetary hydraulic motor rotors, but also to significantly increase the absolute value of the flow area. In turn, an increase in the flow area of the distribution system made it possible to increase the nominal value of the output power of the hydraulic motor as well as to stabilize its output characteristics. Thank you for your attention. Considering our unstable connection and the fact that the research team is on the temporarily occupied territory of Ukraine, we would be grateful to receive your questions in a written form through any communication channels, our emails, Viber, Telegram, WhatsApp, and so on. Thanks for understanding. Our sincere greetings to all the participants of the conference. It is a really great pleasure to have an opportunity to meet our colleagues today to exchange and discuss the latest ideas in design, simulation, and manufacturing. We hope for intensive and productive work and new contacts for the future cooperation. Well, our purpose today is to talk about the relationship between an orbital hydraulic motor design and the dynamic characteristics of a hydraulic drive. So to start, I'll cover some points of the introduction and outline the major challenges. Nowadays, orbital or georotor hydraulic motors are widely used in power hydraulic drives of working equipment and movement mechanisms of self-propelled machines. One of the disadvantages of the considered hydraulic machines is the unevenness of their output characteristics, which occur during transient processes. That unevenness is usually the result of an error in the manufacture of the toothed surface of hydraulic machines' rotors and the pulsations of the working fluid flow inside a distribution system. The analysis of the publications related to the problem of stabilization of the hydraulic drive output parameters showed that the issues on the relationship between an orbital hydraulic motor design and the dynamic characteristics of a hydraulic drive have not been considered. To stabilize the hydraulic drive output parameters when a hydraulic drive is being designed for self-propelled machines, one of the important tasks is to study the influence of structural elements of hydraulic machines on the change in the characteristics of the entire hydraulic drive during transients. Therefore, the current research included the study of the influence of an orbital hydraulic motor design on the change in the dynamic characteristics of a hydraulic drive during its operation in transient states. Moving on now to our aim and research tasks. The research was devoted to the study of the influence of an orbital hydraulic motor design on the change in the dynamic characteristics of a hydraulic drive in order to stabilize the output parameters by modeling transient processes that occur during the operation of hydraulic drives and self-propelled equipment. To achieve this goal, the initial data and conditions for simulation of the transient processes occurring in the hydraulic drives of self-propelled machines were substantiated. That enabled simulating and studying the influence of the design features of an orbital hydraulic motor on the dynamics of changes in the functional parameters and output characteristics of the hydraulic drive during the operation of self-propelled equipment. Right, let us go on with the research methodology. The studies were carried out with two orbital hydraulic motors with the same working volume, the moment of resistance, the moment of inertia of the rotating masses, the volumetric and the hydromechanical efficiency. At the same time, the gap between the teeth of the rotors in the second hydraulic motor was decreased, as well as the fluctuations in the flow area of its distribution system were eliminated. The results of the previous theoretical and parametric studies made it possible to study the change in the functional parameters and output characteristics of hydraulic drives of self-propelled equipment during transient processes, depending on the change in the geometric parameters of orbital hydraulic motors. The pump feed unevenness and the change in the load on working tools, expressed by the moment of resistance, was set by the expressions on the slide. Two next slides will present the dependencies which were built to model the changes which can occur in a hydraulic drive using self-propelled machines during acceleration of the drive. On the current slide, you can see the model of the changes in functional parameters such as pressure, flow rate of the working fluid through the hydraulic motor, and safety well considering operational conditions. Here you can see the modeling of the changes in output characteristics such as torque and speed of the hydraulic motor shaft. Outlining the results, we should say that actually, the modeling and studying of the dynamics of changes in the output parameters of the hydraulic drive with an orbital hydraulic motor was carried out using the VISIM dynamic simulation system. The developed structural and functional diagram of the dynamic model for a hydraulic drive using self-propelled equipment allowed us to simulate the transient processes which occur in hydraulic drives under operational conditions depending on the design features of rotors and distribution systems of the orbital hydraulic motor. As a result of the research, we obtained the dependency that characterized the changes in the functional parameters such as pressure and flow of the hydraulic system. The analysis of the presented dependencies showed that the investigated moment of acceleration of the hydraulic drive could be divided into 3 stages: starting of the hydraulic motor shaft, direct acceleration, and steady motion. The duration of the first stage, the startup of the hydraulic motor shaft, for both hydraulic motors was the same. The period of the direct acceleration was 12% less for the first hydraulic motor than that for the second. Analysis of the pressure change in the hydraulic system showed that at the first stage there was a large pressure jump which 5 times exceeded its nominal value. At the second stage, the pressure sharply decreased and stabilized at the value which 1.8 times was higher than its nominal. At the same time, the pressure in the first hydraulic motor had insignificant pulsations with an amplitude of 3 to 4 megapascal. The pressure pulsations were caused by the fluctuations in the flow area of its distribution system and pump flow pulsations. There were practically no pressure pulsations in the second hydraulic motor. Analysis of the pressure changes in the hydraulic system at the third stage showed that it decreased, reaching its nominal value. However, in the area under consideration, there were significant pressure fluctuations caused by the pump flow pulsation and the fluctuations in the moment of resistance with an amplitude of 15 megapascal for the first hydraulic motor and 10 megapascal for the second one. So that was 34% less. In the current slide, you can see the changes in output characteristics such as torque and speed on the hydraulic motor shaft. Analysis of the results of investigation of the change in torque depending on the gap between the teeth of the rotors showed that for both hydraulic motors at the first stage there was a quite large jump which was more than 5 times higher than nominal torque. At the second stage for both hydraulic motors there was a sharp decrease in the torque value, 1.8 times exceeding its nominal value. In this section, the torque of the first hydraulic motor had significant pulsations with an amplitude of 140 to 150 Nm. The pulsations were caused by an excessive gap between the teeth of the rotors. The fluctuations of the torque on the second hydraulic motor shaft in this section did not practically happen. The third stage was characterized by significant fluctuations in the torque caused by the fluctuations in the moment of resistance, with an amplitude of 300 Nm for the first hydraulic motor and 2.5 Nm for the second hydraulic motor. That was 17% less. The analysis of changes in the speed of the hydraulic motor shaft, taking into account the design features of the distribution system, showed that for both hydraulic motors at the first and second stages, the speed values increased. That could be explained by the radial clothing of the safety valve. At the third stage, the speed values, having reached their nominal value, stabilized. However, there were slight pulsations caused by the pump flow pulsation and sinusoidal protuberances caused by the fluctuations in the moment of resistance. To make the conclusions, we would like to summarize that the developed structural and functional diagram enabled to model the transient processes which occur in hydraulic drives of self-propelled machines and study the changes in the dynamic characteristics of a hydraulic drive considering the operation conditions. It was found that the acceleration time of the second hydraulic motor was 12% less than that for the first hydraulic motor, while at steady state motion, the pressure fluctuations were less by 35%, and the torque fluctuations were 17% less. Such changes were achieved due to the decrease in the gap between the teeth of the rotors in the second hydraulic motor, as well as the elimination of the fluctuations in the flow area of its distribution system. Well, that is all. Thank you for your attention. As well as our colleagues from the previous team, we must confess that unfortunately our internet connection is not stable. We will try to take part in the discussion and answer all your questions, but we would also be really grateful if you send the questions to us via email or other messengers. Thank you.
Thank you for presentation. There were three interesting studies. The first one was reducing working fluid pulsations in planetary hydraulic machines by rational design of the distribution system. This was presented by Oksana Yeramenko, presented by Oksana Yeramenko, Mamadamas Abdullo, Natalia Voltyanska, Stefan Mikalenko from Dmitry Motorny Tavriya State Agro-Technical University of Ukraine, Tajik Technical University, Tajikistan, and State Biotechnical University of Ukraine. In this study, the influence of changing the throughput of distribution systems on the output characteristic of planetary hydraulic machines was studied to ensure their stabilization at the design stage. Here, the design schema and mathematical apparatus were developed. The initial data were substantial, allowing to study the influence of change in the geometric parameters of the distribution system on the pulsation of its flow area, depending on the kinematic schema and angular gap between the distribution windows and the number of the additional windows. The second study, unfortunately, was broadcasted without sound. But this study was model of the kinematic position of units with a discrete method for control dynamic characteristics. The study was prepared by Mikhailo Cherkashenko, Alexander Gusak, Alexander Patiev, Nadezhda Patieva, and Alexander Zeti from National Technical University, Kharkiv Polytechnic Institute, Ukraine, and Sumy State University, Ukraine. In this study, an algorithm for analyzing the position and function was developed. This algorithm allows providing the specified technical characteristics of the kinematic position of units by describing the necessary law of change in the effective areas of the control line. The results of this study can provide the specified technical characteristics for a smooth acceleration of the kinematic unit output member. Additionally, formulated laws of motion allow movement at the steady speed and smooth braking with stop at the positioning point. The third study was the influence of the design features of orbital hydraulic motors on the change in the dynamic characteristics of hydraulic drives. This study was prepared by Anatoly Panchenko, Angela Uleshina, Sharior Sadullozoda, Oleg Voltyansky, and Valeria Panina from Dmitry Motorny Tavriya State Agro-Technical University, Ukraine, and Tajik Technical University, Tajikistan. In this study, a structural functional diagram and a mathematical apparatus were developed to reveal the dynamics of change in the characteristics of a hydraulic drive of self-propelled equipment, considering the conditions of its operation. The change in the stability of the dynamic characteristics of hydraulic drives of self-propelled vehicles were determined under the influence of design features of orbital hydraulic motors. In this study, there are two orbital hydraulic motors. The design differences between these two motors were the gas between the teeth of the rotors and the cross-section area of the distribution system. Based on this result of this study, the acceleration time of the hydraulic motor number 2 is 12% less than that of the hydraulic motor number 1. I think the authors cannot attend this station due to the Russian invasion. Now, I think now we need to end the station, but I really thank you for your attention and also the DSMI team and organization committee for their unbelievable effort.
Thank you very much. Are now in the regions where is active war actions, and that's why they cannot participate online, but their contribution as video presentation definitely will be useful to all participants and listeners for future generations. Thank you very much for you. Thank you very much for other participants in the chat. I must admit that agenda has been completed for today. This day was really intensive, and we received a lot of feedback. I invite you to join us tomorrow. Virtual Hall D will work starting at 9 a.m. By Polish time, and so we will find new information, new trends in advanced materials and ICT for engineering education. Thank you very much, and see you tomorrow.
Bye everyone. See you tomorrow.
See you. Bye.